using load enhancement equipment. That's superlift. Lifting of persons or when the lifting operation is at a location with exceptional hazards. Can anybody give me an idea of what we would have in Qatar would have exceptional hazards? Anybody? First one that springs to mind to me would be Qatar gas when they do the shutdowns, any of the chemical plants, or maybe even you have to work over a electrical plant. You're putting new generators in or something like that over live equipment. We'll get on to that. Now, additionally, to those mentioned above, in this region particularly, I've noticed that your project management teams always seem to write in this thing called critical lifts. Now, this is an American thing that's come from the OSHA standards when a load exceeds 75% of chart capacity, and also blind lifting. This is when the operator can't see the entire load path from pickup to set down. Again, all complex and critical lifts require risk assessments and method statements with the involvement and approval of an appointed person. Now, I'm going to make a big note here for those of you that may think that topping and tailing isn't a tandem lift. It is. There's two cranes on it, and there's a load share involved. And I'll show you that later on, how it can go wrong. Prohibited lifts. Now, we've all seen them. This is, I'm working to what's best practice, and it's come from a long line of history and incident review and reflection. Now, pallets without pallet forks and netting. Can anybody tell me why? Hello? Okay.
कोई responsibility लेना नहीं पड़ा और सही भी है वो तो एक security भी है ना.
Can I request the participants to mute the mics if you're not sharing or asking questions, please? It's disturbing the others.
Anyway, the other one's loads with loose components or materials because they may fall off. Now I'm going to give you two main ones here. No tandem lifting with using tower cranes and no topping and tailing lifts with tower cranes. Can anybody tell me why you wouldn't lift waste skips with the lugs and the chains? You know those small little boat skips that go on the back of the truck and the guy comes along and picks it up and he puts the lugs over puts the chains over the lugs and lifts it on the back of the truck. Can anybody tell me why you don't go lifting those around the site with a crane? Anybody?
You can unmute your mic and share.
Okay. A large majority of these skips, they're not third-party certified. They wouldn't need to be because they're only rated for duties picking up and putting on the truck, probably no more than 1.5 meters off the ground, and then slid with the arm, hydraulic arm onto the truck. These lugs have a tendency not to be tested. The welds can rust, they can be damaged, and they fail. And if you can imagine your chains on them, slinging it over a site, and then one of the lugs fails, it's just going to be a...
Hello, Mr. Bray. Hello, Mr. Bray.
Hello?
Hello. Yeah, please, I have a question.
Yes, sure.
This waste key, if it is to be lifted using crane on the site, let's assume in a scenario whereby we have a waste key inside a tunnel and we need to use our crane to lift from the tunnel to the ground level, you understand? Like a shaft or a tunnel. Is it not mandatory to certify this waste skip?
If you want to do that, if you want to have that thing tested and have it load tested, not mean some guy from a third party just come out and tap a hammer on it. It needs to be load tested off site. So if you want to do that, that's fine. And you can put a certificate on it. But generally, people don't do that. They just see it on the site. It's got something they can pick up. So I would recommend that, but I would have the welds checked, I'd NDT tested, and then have it tested to 2 times the safe working load and put it into service. Great idea. But generally we don't lift them because they're rogue and we don't know where they've come from. They're like orphans. Any other questions? Anybody got any questions about tandem lifting with tower cranes and top and tailing using tower cranes?
Sorry to disturb. Many of these waste skips are with paddy also, which has been manufactured as per paddies or designed as per the old standard 12079. When I was in Qatar, we have tested many waste skips with these paddies.
Yeah.
So for lifting, we have been using the dedicated paddies for that.
Well, you've got pallet forks, right?
Pardon, sir?
You were talking about pallet forks or waste skips?
No, waste skips.
Okay. Yeah, it's not a problem. If you want to have them individually tested, put a serial number on it, get it through the system and have a third-party certificate and put that in your lifting gear register. Carry on, but the majority of people don't do that because every time they fill it up, it goes away with a truck, and then a different one comes back. But if you've got a closed loop where the one you're getting back is yours, and you know that it's not gone anywhere else, and somebody hasn't put like 6 tons of metal waste in it and overloaded it, then get a safe working load on it, get a serial number and a plate on it, and have it put in the system. But generally, I wouldn't lift with them because there's far too many just random ones.
Agreed.
Anybody else? Okay. Now we're gonna. This is the topics we're gonna touch. The first one's gonna be get into the what you're all interested in, probably multiple crane and tandem and lifting. Now, these should only be carried out when it's not possible for the load to be lifted by a single crane and when prevented by. Now, if you can't, the best thing to do in any case is just to keep going up on the capacity and trying using it with a single crane. But if the load weight's above the chart capacity, physical dimensions are too large, or the characteristics of the load, maybe it's got lifting points at either end and it's a bit fragile in the middle or not very flexible, needs a lifting beam, and the lifting beam might actually take you over capacity for rigidity, and the center of gravity might be at one end or eccentric. For mobile crane, tandem lift. Sometimes you may have difficult movements. You may have to put the load and move it a fair distance, or you've got access restrictions. So all these are probably setting you up to do a multiple crane or a tandem lift. But if you can at any point, always look at using a single crane. It's far safer. Okay, now there's a lot here on the planning, but the main things to take away from here is you need to do a site visit. You need to go out and establish where the services are, ground conditions, access and site restrictions. Can anybody tell me why you would carry out underground conditions? Okay, so you actually need to look at the ground conditions to establish if there's any buried services, because if you set up one of these large cranes over a manhole or a pipe run or a duct run, you could A, crush the service, B, it could tip the crane over. And also you need to do ground bearing pressure tests established where you're going to set the crane up, just to make sure that the ground can take what you're actually going to put on it. Now, the main thing is to know the characteristics of the load. You need to know everything about it, okay? You need to know the weight, the unit weight, the center of gravity, the distance between the center of gravity and the lifting points, how many there are, so you can work out later what's called the load share. And this all depends on the center of gravity, if it's high or low, and how much you can rotate the load, get it out of sequence. It's all down to that. So when you're calculating this, it's best to get the people that manufactured it, and they can give you the load quite accurately. When I worked at the airport, I was doing gantries, tandem lifting every day for like 10 months. And I could phone up the people in France and they would tell me exactly how much this 30-ton gantry weighed within a couple of 100 kilos and exactly what the center of gravity was. So it was so easy to work out my load share. Okay, so where are we now? Okay, next one. Now, when you've worked out how many cranes you may need 2, you may need 3, you may need 4, and you've worked out the load share, it's best to add on, here's an industry practice, 2 cranes, add 20% on from your load share. 3 cranes, 33%, 4 cranes or more, add 50%. You have a bigger degree of things going wrong with 4 cranes, so you need to be able to take almost half the load again. Now you've also got to make sure the cranes are positioned to ensure that the hoist ropes remain vertical at all times. Can anybody tell me why you need to make sure the hoist ropes stay vertical on mobile cranes?
Brad, I think we have some appointed persons with us. Let's
Okay.
put the question to the audience. Guys, feel free to unmute your mic. It doesn't matter whether you're right or wrong. Let us share the thoughts so Brad can help you. Thank you.
Hi, Brad. Good
Hi.
evening.
Hi.
Hi. So we have to ensure the load lines or hoist lines are plumbed, mainly to ensure that the side loading is not happening on the superstructure of the crane and the boom, which is only
Correct.
designed to take the vertical loads.
Correct. Now, this is a big problem. If your hoist ropes are out and you're putting side loading on a crane, you can fold up a boom quite easily. Thank you for that. Now, you've got to make sure the cranes aren't subjected to any additional forces. So it's boom side loading that would happen when you're carrying out a single lift. Single lift, the ropes will always be vertical. Big thing, check on the competency of your lifting team. Not just that they've got a certificate, but that they can actually do the work.
Excuse me, Brad. Can I have a quick query on this about the load sharing when we are using a tandem lift with the 2 cranes?
Yeah.
Let's say the dynamic load, how much percentage we calculate for the, we will take care in the calculation for each crane. Let's say 100 ton, how much percentage we can take on the load calculation on each crane?
Just say it's a simple tandem lift. It's 100 ton and each crane is taking 50 ton, equal load share. You magically got it that it's 50 ton on each, 50-50 split. You would then take 20% of the 50 ton and add that. So you're going to add another 10% onto that. So you make sure your safe working load of your crane can take 60 ton with your factors that you have. Now there's other factors that you need to add on top of that, which like wind loading and wind surface area. And but this is the total weight under the hook with the lifting beams, the shackles, the slings, the hook block, everything. And it magically comes to 50 ton. Then you would add another 20% on for 2 cranes. Is that clear?
Hi, Brian. One doubt. If you're going to do a tandem lift with 2 mobile cranes, and to find out the permissible wind speed per crane, how are we going to divide the surface area? Percentage of the load sharing, or how are we going to divide the permissible wind speed for both the cranes?
Well,
Before calculating the,
that comes from your calculations. You basically take the each of the load points, and then between the 2 load points, you take the halfway point, and then you work out, everything's based on the center of gravity. So you wouldn't actually have 1 crane over the center of gravity because it would take everything.
Yeah. Basically, my question is that, for example, if there is a load, if there is a crane, if there are 2 cranes going to lift 100 ton load, imagine, and 1 crane is bearing 55 ton, another crane is bearing 45 ton.
Yeah.
And with respect to the center of gravity, and when we are going to estimate, and imagine both the cranes are having different rated wind speeds. So if we want to find out the permissible wind speed for both the cranes separately, we need to know the sail area of the load. Imagine the surface area is large and the weight is less, if that is a scenario. And if we have to find out the permissible wind speed in that case, how are we going to, so the total sail area we have to calculate and take the 45% to one side and 55 to another side. Is that we have to do?
You work out your load first, and then you add this 20% on, and then you work out the wind sail factor. You're only giving yourself with this 20% a safety margin, just for not equal load share. these calculations for the wind and the surface area are something you fine tune with at the end. You get all your load up, and then you work out that, and then you see if you've got that within your 20% margin. There's various ways to do it, but I'm just looking at simple ways at the moment that you basically, once you get above, if you're lifting a large surface area with a sail effect, then you've got to negate your wind before you even lift. So you have to basically set yourself a threshold. Like say the crane's maximum operating speed is, wind operating speed is like 9 meters a second. You would probably have to say, we're not lifting that any more than 6, because the wind pressure will take that out of radius or move it, add more pressure onto it. Does that make sense? Hello?
Okay.
If
Yeah.
you've got like 45 and 55, I would add 20% to 45 and 20% to 55. The load you're calculating
No,
is
no,
way more than real load.
it's not about the load. Imagine one crane is having a rated wind speed of 13 meters per second, and another crane, which is with respect to the configuration, it has got a rated wind speed of 9 meters per second, and the load has a sail effect due to the heavy, large surface area and less weight. In such case, if we have,
You would work to the lowest one, but I would always be trying to stick to cranes of the same type. Now, if I'm going to use 2 mobile crane telescopic boom cranes, I mean, the ideal way, and everybody says you're supposed to use 2 cranes of the same make, same capacity, so that you've got the same hoist speeds and hook speeds going up and down. But you can say, this is a 100-ton mobile crane, and this is a 90-ton mobile crane, or this is a 300-ton mobile crane, or this is a crawler. So it's best to match your cranes. So if you've got like a 100-ton crawler crane and a 500-ton crawler crane, they both will have, with the lattice jibs, the same maximum working speed. But if you have one with a higher one than the other one, you work the lower one. And you shouldn't really be mixing a mobile with a crawler crane. They're 2 different animals. It's kind of best to use both mobiles or both crawlers.
Okay.
okay.
Hello. My input on that is my name is Patrick from Nigeria. Whatever contingency you have on each of the cranes, you look at the load sharing.
Yeah. So what I've done here is you take, like, let's say the load is 100 ton. You have 50 ton on A, 50 ton on B. You then say, right, I need to add a safety margin of 20%. So I'm now pretending I'm going to calculate my safe working load for 60 ton and 60 ton. And then you go to your chart and find out what it can do below the on the chart capacity. That answer your question?
Mr. Brad, I have a question.
Hello?
Do you hear me?
So we can't hear you.
Can you hear me?
No, Brad, we can hear you. The person who asked the question.
Yeah. Okay.
The audio is very low.
Oh, my audio is very low. Okay, sorry. I have a question. During the tandem lift.
Okay, I'm gonna move on.
Oh, okay.
I'm not sure if we all got that, but it's not a difficult one. It's just a safety factor we're adding in. It's a bit like the 75% chart capacity that the clients don't want you to exceed 75% of 75%. You're giving yourself a safety margin. Now, into that, you would then add on your wind and your any other calculations. There's a load of little tiny ones, but they don't affect the load that much, because if you're taking a 9.8 meters per second maximum operating speed for a crane, and you've got a massive sail effect, then straight away, you're not going to lift that above, say, 6 meters a second, which is, you'll see when 6 meters a second happens in Doha, because the dust will start lifting off the ground. Okay, so make sure your cranes are positioned to ensure that the hoist ropes remain vertical all the time, and check on the competency. We've done all this. So I'm going to head on to the next slide. Oh, the last question, last two are, ensure all your equipment has been inspected and has valid certificates in place. And the big one, I go on the map for Qatar when I was there, and I would look for quite accurate wind speeds because it's designed for sailing, a complete forecast for every 3 hours of the day. So if I knew it was going to be windy on a Tuesday, and I was looking at this on a Sunday, I would basically be calling the lift off because it's quite accurate. They know within a couple of hours. So if it's going to be windy all day, Tuesday and Wednesday, I wouldn't even be scheduling a lift that day. I would be pushing it to the Thursday.
Yeah.
But
Excuse me, Mr. Brad. Excuse me, Mr. Brad.
Yep.
Yeah, this is John. Sorry for interrupting you. Yeah, I was a little bit concerned. The explanation you made regarding the safety factors that we have to, adjustments we have to make on the capacity of the crane, in reference to the chart. Now, how about the age of the crane? Does it have a way it affects our decision in terms of the safety factors that we need to put on? Because I'm just looking at that. The older the crane, there's a tendency that we need to make some reasonable adjustments in reducing the expected load that we should carry. In other words, increasing the safety factor. What is your thought about that?
I basically have a rule on site that if it's just dragging itself on site, and my procurement have got me something that looked like they got it out of Street 33 in the industrial area, I send it away. I generally don't like using cranes over 10 years old. I find that unless they come from decent companies, they're not very well maintained. And if we're worrying about the structure and we're having to derate it unofficially, that's not good. So when I'm doing tandem lifts, I'm usually lifting pieces of equipment that have a high capital value, and the cranes also have a high capital value. So I wouldn't be trusting it to a broken down 15-year-old Cato crane that's been held together with duct tape and cable ties. So if you're put in that situation, I would probably have the crane load tested before you even carry it out. And actually pick up the load with the same sort of load and see if the crane can handle it and have it third-party certificated. Because the third-party certificate, as we all know, is only valid on the day it was done. I mean, next day it's technically you have a certificate, but if something goes wrong with a crane, third-party people aren't liable. Do you want to? Have you got any? Can you ask me something else on that?
Hello, Mr. Brian. Hello, Mr. Brian.
Yeah.
Hello, Mr. Brian. Can you hear me?
Yeah.
Yeah. Concerning the question which was just asked, I'm so interested, and it's a very, very good question from the person that asked the question. In recent situations we have in some of the projects I know, I have seen where a crane of 24 years, 30 years is brought to site.
Yeah.
Okay, as per construction situation, you have to make your lifting plan based on the cranes which are provided for you as the appointed person. You cannot sometimes go against your complaint, like they are giving you a crane and you are saying, oh, I cannot use this crane. Sometimes people are scared to lose their job. You understand?
Yes.
So in this situation where we have, is there any standard which could back up the age of the crane? Like when you want to send an report, an email to the company, is there any standard which can specify the age of the crane used for particular critical lifts? Like can say, as per this standard in reference, this age of crane I cannot use. Is there any standard to that? Sorry. That's just my question.
Not in the QCS as such, but let me the British Standard 7121 Part 2 has
Part 2, okay,
is broken down into Part 2.1, 2.2, 2.3, 4, and 5. Now 2.3
Part 2.1, 2.2, and 2.3.
2.5. Now 2.1 is a general maintenance for cranes. 2.1, 2.3 is the general maintenance for mobile cranes, and the 2.5 is a general maintenance for tower cranes. And in there are special things. And I'm going to go on memory here, but I think there's a list of scheduled maintenance that has to happen to a crane up to 16 years old. Now, at 16 years old, technology has moved on so much that I'd be surprised that they're actually got a calibrated RCI. You would be getting in the cab and there'd be like 4 sticks instead of 2. I'd be worried about pulleys and slew rings. I mean, even the structure starts to break down after 10 years with rust. And I touched on this a few years ago where there was cranes at the time before the embargo, they were buying a 2001 Cato crane, sending it to Dubai from Saudi, painting it in the free zone, giving it a new plate and sending it to my project and calling it at the time a 2009. And that this was at 2013. So you can imagine what they were doing. They were taking 13, 15 years off the crane. Now, I touched on this in a previous discussion. If you look at the serial number plate, and the serial number plate is like a little tiny plate about 2 inches by 3 inches, and it's generally somewhere on the slew ring or in that area on the top part of the crane. Now, if that's held in anything else but rivets, if it's held in by screws, like drywall screws or glued on or whatever, and the number, you can take that number and you can go to the manufacturer in Doha or the supplier, the rep, and they will tell you exactly the age of that crane. And some of these cranes, if you've got a crane newer than 2010, it should only have about 2 sticks in the cab. If you've got a crane with 4 sticks in the cab, 4 in a row, and there's rusty holes in the floor, you can safely bet that that crane is in the 1990s, early 2000s. You should get in a crane now and it should look like you're sitting at like Captain Kirk's thing on Star Trek. You should just have 2 controls, nice seat, and a console in front. And that's been from 2010, which is 11, 12 years. I know your procurement always go to the bottom line for prices, but when you actually pay a bit more, you've got to convince your procurement that the breakdown time is going to affect you directly. Now, if I told you that some of the cranes that I've had from these cheap and nasty suppliers break down 4% of the time, that's 4 hours every 100. And I can pay a bit more and have a crane that breaks down 0.2%. It breaks down 2 hours every 1,000. So you've got to weigh that up, and you've got to go back to your commercial team and your project delivery team and say, it's false economy. And the risks of, I've seen ropes so badly damaged that when they drive on the site, they're broken in 6 or 7 different places and we have to send it away. And your health and safety team should be backing you up, and your procurement are the people that have put you in a bad place. Okay?
Yeah, you have a good point. However, I'm telling you a lot of scenarios, even nobody is ready to get you involved in the procurement. You know a lot of situations, and especially the cathode cranes. I see now most of them are 20 years, 15, 18 years above, especially the cathode cranes.
We used to drive by a project in Doha and it had that many old cranes. We used to call it Jurassic Park because it just looked like old dinosaurs standing around. And it was procurement. The people just get in and they go, oh, who's got the cheapest price per month? But if you've lost a week because something's broken down, you're in the middle of a lift and the hydraulics go, and you've lost a concrete pour the next day, you work that cost out. When you get a crane in from, I don't know, Sarens or Manai or some of the better ones, and your breakdown rates are like 4 hours and 1,000, then, and they do regular maintenance. That's the problem. These cranes that are cheap and they get them on, they only fix it when it breaks down. And when it breaks down in your time. They might not bill you for the 4 hours. Oh, great. We didn't bill you for the crane at 400 reals, but I've lost 4 hours, 50, 60 guys, can't do any shutters. can't get the concrete pour done for the end of the day. And you look at that cost, but you saved, hey, we saved a day on the crane. So you need to go back to these people and beat them with economy. It's false economy. I've seen enough scrappers in Qatar. You drive down Street 33 if you're ever bored and see the man with a little plastic lawn chair, and he'll sell you one of them for whatever the daily rate is. But you don't know where they've been. You don't know what they've lifted. Some of them go out and get a third-party certificate, and then the next day change the rope to the old one. It's not very well managed. Anybody else want to talk to me about false economy and cranes?
Yeah, I would like to add something. I think I remember reading up somewhere in QCS that for best practices that we should not allow mobile cranes older than 15 years. That is applicable in Doha. It should not be allowed to, in the work site, as a guy. And I think in my workplace, we also use this criteria, and we use it to disqualify certain cranes that comes. And then I also like to point out something that you said that I like, that we are able to find out the actual age of a crane from the serial number, right? Is that right?
Yeah.
Yeah. And then you mentioned that we can find the serial number at the top of the head of the crane. Is that correct?
Yeah, if you walk down the side of the crane, and on one side of the slew ring, there should be a little plate about, maybe 1.5 inches by 3 inches. And it should be stuck on the side of the slew ring, and it should say Tadano, Cato, Liebherr. I can send some stuff to Malavan and he can send it to you. But generally that should be held in with like factory rivets, not rivets that you buy from Ace Hardware or something.
Because oftentimes the age of the crane, we often rely on the third-party certificate that is issued. On the third-party certificate, they often write the year of manufacture. They always write the year of manufacture. So that is what we rely on.
Yeah, and what happens is when they came in the country before the embargo, they would come in with a false plate, and then they would get an Istimara based on that false plate, and then they would get insurance, and then based on the insurance and the false Istimara that they got, well, it was a real Istimara, but when they were driving from Dubai, they were getting their life. It was basically like turning up when you're dating a girl and she tells you she's 25 and she's actually 40. So you can tell she's 40. She looks 40, but she's saying she's 25, but she has an ID card to say she's 25. And this is what's happening with these cranes. They're in the country now, and the third-party people know it's an old crane, but because they have a document that they know isn't right, they just keep telling it, furthering the story. I don't want to mention any names of third-party companies, but it was quite rife back in the railway 2015, 16, 17. Qatar Rail said that no plant on the job could be more than 5 years old. So this forced a lot of people to buy these cheap cranes and have them re-aged or the years taken off them. 1990 Cato cranes telling me they're 2010. You'd get in and you can tell when technology in 10 years has moved on. A crane nowadays should have two sticks in the cab. If you see anything else with 4 sticks, 1 for each movement, most of them now have 2 sticks, 2 movements in one, 2 movements in the other, either side of the seat. And you can tell just by getting in with the amount of rust and breakdown of how old a crane is. You wouldn't buy a car that somebody's trying to tell you is 15 years newer than it really is. So I don't know why we accept this in the crane industry.
Brad, shall we proceed?
Yeah,
Shall we go
thank
more?
you very much.
Okay, so if you really want to look at wind speeds, and I plan my entire rigging teams around the wind speeds and what they can lift, and that's at WindGuru, windguru.cz or something. You'll find it quite easily, and then you can track where you want to, which forecasting sites next to yours. Okay, so I'm going to scroll down to the next one. So during operation, you need to specify one competent person in charge. There's a tendency when everybody has big cranes and everything's going on, as lots of people come out and confuse the operators, and somebody thinks they know better. You just got to stop it. You got to put a total exclusion zone around. I know you're going to have the client down there. You're going to have all the engineering supervisors down there. You're going to have probably the project manager. You're going to have an audience, and everybody wants to jump in when something goes wrong. You've got to appoint one guy and monitor that exclusion zone, one guy. And it's normally an experienced crane supervisor. And if no one else, the appointed person takes over because it's his responsibility. This is the only person to direct the crane operators with instructions. Now, the communication method between the crane supervisor and each of the crane operators is critical. And this is to enable unison in movement and also to ensure safe lifting. If it's possible, and you can see the operator, and you can see the load, and you can see all the operators, hand signals may be used. But whatever you decide on, stay committed to the communication plan. Don't start changing it halfway through. Whatever you've written down in the communication plan, follow it through. Now, the cranes, they're big, they move slow. The bigger the crane, the slower it moves. So ensure there's only one motion at a time and in the same direction at low speeds. So if you pick the load up, pick the load up. If you want to then slew right. Don't try and go diagonally up and over at the same time. It'll just cause you problems. Put side loading on the crane. So just break it down into steps. I want to take it up. Okay, I want to move it right. Okay, and I want to boom out. That's very simple. Now, when you're doing all this, make notes with the operators every so often to check the load. Crane A, what's your load? Crane B, what's your load? You may see some fluctuation throughout the lift. This is when the cranes get out of sequence. So if you're lifting up and you're hoisting up a long way, one motor might be faster than the other. So you may have to say, hold crane A, carry on crane B. Okay, we're level, carry on. But your crane supervisor should be able to do that. And I've seen some really good guys just do it with both hands, and they've just got their fingers pointed up and they're like rubbing their thumbs and fingers together, and everybody's in like, it's like an orchestra. And if you're traveling crawler cranes, make sure they travel in the same direction. They're both going forward. They're not opposing each other and twisting. Any questions on that? We're going to go to the next operation one. Tips. Okay. Some of you might have heard about shock loading. It used to be something very common years ago, before they had really accurate RCIs. But you use the RCI almost like scales, bathroom scales. And what you do is, say you've got 15 ton on either crane, and that's your load share. And you worked it out with a hook block and everything, just for sake, it's 15 ton. So you would take your crane up in increments equally. Go to 5 ton, go to 10 ton, go to 11, go to 12, go to 13. And then when you get about a ton below your calculated load, start going up in 100, 0.1 of a ton increments. Now this is slowly going up. 14.1, 14.1, 14.2, 14.3. And when you get to the calculated load, hold and check. Very rarely will you get it exactly right. One crane might be off the ground by an inch, the other crane might still be sitting on the ground, but the loads are close. So if the crane's off the ground at 15.1, you just hold him there because he's off the ground. You take the other crane out 15.1, 15.2, you may find you have to go to 15.3. Then the crane will equalize out 15.1, 15.3, and that's your new load, okay? And then up you go. Once the load's on, unless you start moving it around the center of gravity, the load should stay fairly constant, unless it's a top and tail. Now check these load values against the calculated on the plan. So once it's off the ground, check, because you may find that somebody's added some stuff on there, put you 2 tons over on each crane, and you're now into your safe margins. At this point, if it's over by a big margin and out of your safety margin, only you will know what you're comfortable with, like 5% over, 3% over, it's in your margin of error. If it's bigger than that, put it down, recalculate. You may have to go back and look at shaving your margins, or maybe you've got enough buffer, but always check your load. As soon as it's clear, check. There's nothing worse than trying to boom out and finding out that you've already lost a couple of tons off the radius, a couple of meters off the radius. It's not worth it. So as we were taking the pressure up to get it off the ground, on the set down, when you say you're landing it, make sure you maintain the loads on both cranes until the loads are secured. Now, if you can imagine, you set one down, and then you think you're just going to lower the hook and get rid of it, and the other crane will then take more load, and it can be up to like 30–40% more, because the load will shift, the center of gravity will shift. There's a whole new dynamic with the load, because you're actually picking a cantilever. So a quick release on one crane will rapidly increase the load share on the other. So that's where we get shock loading. So everything gets done slowly. So if you fixed both ends of the load, then you can depressurize the crane, take it from 15 down to 14, 12, 11, and then take the hook off. Another good tip, if you want to make sure the hoist ropes are vertical, is to drop the plumb bob by about 4 meters and drop the auxiliary hook block by about 4 meters. And this will give you almost like a very simple plumb bob. Okay. Now, also, if you happen to get into this high risk traveling crawler cranes on a tandem load, which has been done, and if it's well planned, ensure that the drive sprockets, this is the big gear that drives the tracks, is at the back. Because if you can imagine, if the crane's going forward, it's pulling the tracks underneath it. If you get it the wrong way around, you'll be pushing the tracks underneath it, which is not where you want to be. And also make sure the operator's cabs are both facing the same way. Any questions on those? They're just things to make your job easier.
Brad, there are 2 questions on the chat, may or may not be directly related to what you're saying. Do you like me to read it, or could you read?
Yeah, sure. I can't see anything.
No problem, no problem. Okay, question from Vijay Kumar. Can mobile crane be used for piling, like lifting a load and then make a free fall to have an impact on the pipe to drive into the ground?
Wow. I don't.
Hi, Brad. Hi, Brad. This is Viju. That question was raised by me. Like I was like long back, like maybe 7 years ago, I was working with a company where we are trying to drill a well for our installation project. So one of our operation manager, he brought in with this such weird idea of using a mobile crane to as a piling, to just drive in the pipe into the ground using a mobile crane, just lifting some weight and then dropping it off on a free fall so that it has an impact on the pipe and then it drives into the ground. So just checking.
Was this a mobile crane or a crawler crane?
It was a mobile crane.
Wow. No, I would say when I was in the Army, we used to do rapid airfield repair, and we used to pick up a great big heavy flat weight, and we'd fill in bomb craters with a layer of earth, and then we'd have a big crawler crane, like a 100-ton crawler crane, drop this heavy load on free fall onto the ground, and it would compact it very quickly, and we put another layer in. For the life, see the crane's going through, it's shaking, it's rattling. Now a lattice jib crane, if it's specially designed for that, can do it, but I wouldn't trust a box girder mobile crane to do it. You'd just be adding stresses that you don't know where they're coming out. I've never been asked this before because I've never done it. I would never do it. I'm sure
because this just came into my mind because we had the same experience. So I thought I will just ask with you about it.
Yeah, I think what you need there is like one of those drilling rigs. Or they used to see them in the old days, but it was always a crawler crane doing pile driving. Never.
Actually, the situation was like they brought in they
always
drilled
on
the whole
track. And
no, already they did the drilling, but again there was some water seepage from bottom, and they were trying to drive in the pipe. It was not going, so they just thought to do that way. But we had a near miss on that same time, so we just stopped the work and everything, and there was a big inquiry on that, and the person was removed from the company itself, like he was terminated.
Yeah, I don't think the rental company or whoever owned the crane would be too happy doing that either. I've never been asked this because it's just one of those things I would never do. I'm sure if I look through the books, I could probably find the exact clause in the BS 721 Part 3. Okay, so we've done the tips for multiple tandem lifting. Here's a picture. I don't know if any of you have been in the airport, but this is the Airbus 380 hangar in Hamad International. And this was a job where we had to replace all the gantry systems because they were needed adjustments. And it was a 10-month contract, just tandem lifting every day. So you get a bit kind of, it's like every day is tandem lifting. So you do have kind of, you get it down to like a party piece after a while. This load here is about 25 ton, 2 80-ton, I believe they're Terex cranes. And these two guys worked in unison for, I guess, the best part of 9 months together. So these are some small loads. We have the big one at the back you see on the far left. Each side was about 42 tons. That thing hanging out to the left of the picture was going up about 40 meters and it was 40 ton. And there was 2 of them in 3 bays. So that was a full-time job. A nice air conditioned 20 degrees C all day long. Now this one is, if you've been in Qatar a while, you know every National Day they seem to do a lot of work out by the by Al Masila when they get the area ready for National Day. And this is in about mid-November every year, this large marquee goes up. And this is a company, I've seen them for the last 5 or 6 years. It's like a party piece. They build the roof on the ground and then they tension it and then they pick it up and then they go around and they put all the posts in. So what you're seeing now is this being held in the air for the best part of 8 hours while they go around and put all the struts in. Yeah, I think this happens about early November, getting first week in November every year. And I think there's a bit of a sandstorm in this picture, but this just shows you how easy multiple crane lifting can be if you get everything right. And notice the crane in the foreground, that's got the auxiliary hook dropped about 4 meters. He's probably using that as a plumb bob. Now, topping and tailing. This by nature is a tandem lift. It's quite hazardous if the cranes aren't working together and side loading can occur on the booms. So this is what a tandem lift looks like. Comes off the truck, horizontal 0, 45 degrees, and then you'll see over here it's almost vertical 90. Now I'm going to show you a chart which is quite easily available on the internet, but it gives you the total load share. And when you're moving the center of gravity and the center of gravity gets underneath the other crane, it will rapidly go from 50-50 or less to completely on one crane. So if you can see one crane, the top crane starting at 440,000 pounds, I believe, at 0, and it's finishing at 670. And the same on the tailing crane, he's starting at 230,000 tons and he's finishing at 0. And you notice it's quite gradual, slowly, gradually up to about 65 degrees. And then you start hitting about 75, 80, 85, it just rapidly decreases. So this is where things can go wrong and the pressures can change quite rapidly. If you obviously know it starts at the full weight and the other crane starts at 0, but in between, this is the gray area. Now, if you're really clever and you do one of these and you can get the operator, magically hold it at 45 degrees and you can go out and start mapping this out, you'll know for yourself. It's nice to have when for future, because you'll see the same scenario come up in your career more than once. Now, what I'm going to show you now is this happened 4 days ago. This is a company that knows what they're doing. They brought 2 cranes in, I think a 55 and a 300. They only needed a 35 and a 160 to do the job. They were taking out a weigh, like a liquid bulk silo for a cheese factory. They were decommissioning it. And they welded on some lugs, on 4 lugs, top and bottom. Now, what happened was on the smaller tailing crane, you'll see on the third picture here on the right that the lifting gear, the lifting points have failed. Now, this is what happened. It was a 12-ton weigh tank, And the only damage, luckily, is this came down and crushed the engine and the engine cowling. So what had happened was, you can see here at the top, the point where it was supposed to be lifted just ripped right off the side. Now, it's thing here, there's no injuries in this one. Okay, we're going to go on to load enhancement equipment very quickly. Now, load enhancement equipment is basically the most common type of this is what's known as superlift. You get a crawler crane in, and they all come with these attachments nowadays to improve them. You'll see it, like most of them are denoted on the load chart SL or something like SB, suspended ballast, in the load chart. There's like 4 letters and a whole bunch of like loads of stuff. There's a 76-page document with the crane, or each load chart for every configuration with fly jib and everything. Now, the crawler cranes use this attachment to improve their power for heavy lifting and extending the radius. Basically, the craning is carrying out a fine balancing act. Some of these, and the counterweight is actually, as they lift, the counterweight gets picked off the ground, and it's basically balancing over the length of the tracks. And it's very, very fine-tuned. Now, if you've taken this crane, when you bring a crawler crane on site, you normally have to have it third-party tested because it's being built. If you set it up for superlift with the load, then you don't have to have an additional third party. But if you set it up for normal lifting and then you add on superlift, you're putting more stresses and strains. And technically in the British standard, it's called a change of configuration and a structural change. So you do need a third-party test, and you will have arguments with the plant people all day long because they don't want to pay the 1,500 reals to have it certified. But you can imagine some of these cranes are carrying up to 200-300 tons of ballast hanging off the back, and all that stress goes through those arms at the top of the crane. Now, your short-term hazards are, you've got a larger exclusion zone for the crane tail swing. You've got an increase in ground bearing pressures, which you may not have considered when you first set up the crane mat on the ballast area. And you have greater stresses on the crane superstructure. So to show you what I mean, here's a 3,000-ton crane. This thing is holding 1,500 tons of ballast. Over here on the far left, you'll see 1,500 tons of ballast stacked up, and it just sits off the ground about a foot, 2 feet at the most. And there it is front on to show you how many plates are stacked on it. And this thing will swing around with the crane in the air, and you can imagine the crushing hazard and the weight on the tracks of this suspended ballast.
Brad, I have a question.
Questions on superlift?
No, it's not about superlift. When you mentioned about the movement, can you put some highlights on the pendulum effects on such cranes when we shift with the cranes?
I'm not. I never get involved with the pendulum effect on that. I don't think they're not swinging around that fast. These cranes rotate that slow that the momentum and the inertia that is there, but it's not enough to swing that out violently. It's not like you're flinging a cat around by the tail.
Okay.
Some of these cranes actually, the superlift actually sits on wheels, and then the wheels sit on a rail, and you would form a large concrete pad, and this would be actually in a frame. So the superlift would come off, but then it would be guided around this track. There's all sorts of things. This is like if you had this crane in for a permanent installation for 6 to 8 months. Okay.
Excuse me, I just want to ask a question regarding rigs. I mean, how the cranes are balanced on the rigs while working on a surface of water? Because I mean, there's a buoyancy force also from the water when the rig's platform is made.
Yeah. Now you've got a crawler crane on a barge.
No, I mean, I'm just trying to understand from your experience that how it works on a rigs area, because of water is having a wave, it's having a buoyancy force. If there is a weight on top, so water will bounce back the same weight So that's what I'm trying to understand.
Oh, right. I've only done marine works where I've had an excavator on a barge, but I've never had a crane on a barge. I've always lifted from the land. I've had a problem with shutters where once they come out, as soon as they clear the surface of the water, they weigh quite a lot, and you have to take that up gradually. But I'm not familiar with putting or derricks or anything on barges or boats. That's not my expertise.
No problem. I mean, the second question I would like to ask is regarding the when multiple lifting, you can say, operation is going on and different cranes are working in a team. So is there any deviation in the speed of movement of one crane to another? Like, I mean, is it standard speed when we move it from right to left, or is it in control of the operator that how quickly they are moving them?
It depends. If you can get both cranes of the same make and model and the engine's just ticking over, you can virtually calibrate the sluice speed or the hoisting speed. But if they're two different cranes, then you almost have to kind of like slew it very slowly and hope the other one goes very slowly, and you can see one guy's trying to keep his hoist rope. It's a fine art, but you've got more chance of survival with a crawler crane because of the lattice girder than you do with a mobile.
Because there are multiple minds involved to perform the same task, and how they're perceiving it could be different. So I mean, it could have impact even if the equipment could be standardized. So there is a possibility that how different operators will perform that task.
It's best to match the cranes. Yeah, if you really want an operator who's not going to just throw it over to the left really quickly. Everything happens so slow. Like I said earlier, the bigger the crane, the slower everything is. If you can imagine, a large crane has like eight, 9 drops on between the main block and the top of the jib. And if you want to go a meter up, it's going to take you 9 meters to get there. So you can imagine how that's kind of how slow that gearing is. Even tracking forward, if you're tracking a crawler crane forward, you would just have the engine just ticking over and you would just say, right, it's just starting to move. And that would be the speed you would use. And you would still have correction to do. I believe the technology is getting that good that you may be able to link these now. I think the better Terexes and that you can actually link these.
So I mean, these distance of movement in different direction and different angles, are they calculated through the laser equipment or something like that, or it's only a rough estimate of a person that he will be moving 10 meter right, 10 meter up, 10 meter again left, something like that?
Yeah, that's at the level that we're doing. I mean, if you get into really complex, really heavy accuracies and high equipment capital costs, then yes, these would be, you can actually get them interlinked. The large Terexes and that, and maybe I can't remember DMAGs and whoever the crawler crane people are, but basically one crane is basically the master and the other crane is the follower, and they're interlinked.
So just like a computer, they interface with each other.
Yeah, that's where they're going.
And that's good. And another question I'm having actually is regarding the grace that we are mentioning here, like 20% to 55%, when there are a number of cranes which are increased, like from 1 to 3 or 4 or 5, something like that.
Yeah.
So is there any calculation for that? Like, I mean, is it a rough guess that we are trying to put, or is there any scientific or mathematical backing for it?
You could, but this is for what we do. It's empiric. It's an empiric rule of thumb that it's everybody in the industry basically adds 20% on for 2 cranes, or they add 33% on for 3 cranes and 50% for 4 cranes or more. It's just an empiric rule of thumb. You could actually go back and work it out, but you're working out like, if this crane failed, or if, like, say you're like lifting onto, and one end had to be suspended and the other end had to be fixed, and you took the pressure off the fixed end before you'd actually fixed it, and it basically caused the other crane to have an increase of weight, that would be your margin that you'd be working in. It would probably be in the region of 10 to 15% if you did the calculations. So these are pretty robust numbers that have been time tested. It's like the when you're doing the ground bearing pressure, working it out for the crane and outrigger sizes, and they've always told you to take 75% of the rigged weight. If you use the lever software, it's down to about 40%, because it's more exact and it has all the details of the crane factored in. So it's 20% is probably way over what you need, but it's a safe, comfortable figure to add on.
I appreciate it. Thank you.
Okay. So moving on, we're going to go to lifting of personnel man basket. Now, this is one of the most simple things, but I reckon if I drove around Qatar and looked at the various combinations and permutations of man baskets, I've even seen people take the plastic thing out of a internal bunded container, one of those, it looks like a pallet with a frame around it and a plastic square for liquids in it. Take that out, hook it up with 4 slings and use that as a man basket. So cranes are not designed for lifting people. That's why you see all these people doing bungee jumping and dining in the sky off them, and people throwing their hands up in shock. It's great, but there's no safety systems like you'd have in a MUP or any other bit of equipment that's designed for people. So you've got to look at, is there another way of doing it? I would always go back to them and push back and say, can you build a scaffold or can you do it with a MUP? And then I would ask, is this a one-time thing? Is this an emergency? Or do you want to do this all the time for a long time? Because sometimes you get these construction managers just lazy and they think that's the safest way to do the work for the next 6 months. I'm going to put people in a man basket for 8 to 10 hours every day. Now your risks go from being frequency of very low to a very kind of almost like possible likelihood. So you need to look at the crane and equipment to be used. I wouldn't use one of those cranes that's over 16-year-old, and I wouldn't use certain types of equipment in the man baskets. Now, the task to be carried out, what are they doing? Are they arc welding? Are they pressure washing? Are they spraying concrete out of it? It's all got to be done. And people, what I throw it back to when I'm lifting is I say, I'll lift it. You give me a method statement. And the method statement has to say how you're going to work safely in the man basket. To me, when I lift, it's just a man basket. And it's got a safe working load. And I've got factors like the wind speed and everything else to consider. But for me, it's just a bunch of people in there. And because it's a critical or a complex lift with people, the people that are working in there have to prove, A, that they can't do it any other way, and they've got a robust method statement. Because you'll find when you're out there on the crane, everybody wants it. It's like a taxi. The man basket becomes a taxi. I've just finished a job in Riyadh, and the only other way on this 300-meter high building was to put a man basket off the tower crane for a year. And sometimes the crane breaks down and you're 40 floors up and you have to break a window to get out of the crane, out of the man basket. Or the operator just forgets and goes for his lunch for an hour. These are the things that add in. So man baskets can be used with cranes, providing the following is in place. You got to have dead man control. So if the operator has a heart attack, then everything stops. Power lifting is fitted. Power lowering is fitted. And there's no free fall. Like we were talking earlier about that free fall in the pile driving. If that's present, you need to lock that out because there's nothing worse than going bungee jumping in a man basket. Crane's been inspected and tested with a valid certificate within the past 6 months. Now, this is where a lot of people forget. They just think the crane's good, so I'm going to throw people on the end of the hook. And it's got to be checked within 6 months. That's a very major one, that you're putting people and you're reducing the risk by doing this. Now, any hydraulic cylinders fitted with devices to prevent movement in the event of a failure. So if your main boom arm hydraulic ram fails and starts leaking and the boom starts coming down, you need to have some sort of device to prevent that. And these things, hydraulic hoses go all the time on cranes in the heat, and they just perish. And control systems that allow for smooth movement, limiting their speed to 0.5 of a meter second maximum. So these cranes should be slowly slewing left and right, slowly booming up and out and booming out, or jib up, jib down. Now they got to be fitted with limit switches to prevent them from going past their limits. The big thing is make sure that little thing at the top of the boom head is there, the little ring, the anti-two block device. Make sure, and I'd say if at the lower end of the cranes, the hook latch, there's a safety latch on the hook. I bet I could drive by Doha and see 50% of the boom trucks and mobile cranes out there with damaged hook latches. The hoist rope diameter, minimum 8 mil, nothing smaller. 8 mil is like the size of your little finger. The crane should have an operational anemometer or wind meter, because the wind speed you take on the ground is not the same as 50 meters up in the air. Also, the crane has to have, the man basket has to have an SWL. The crane has to have a safe working load at the required radius of 2 times the weight of the man basket. So basically you're derating the crane by 50%. So if your man basket weighs 500 kgs all up, then you can only take that out to 1 ton on your load chart. Does that make sense? That's a big one, because people think they can just take that right out to the tip of the crane, 500 kgs. Well, you have to double the weight of the man basket, including the personnel and tools. So there'll be a safe working load on the crane. And if it says this safe working load is 500 kgs, and it's like 4 people in it, that's okay. You just multiply that by 2, and that's your maximum on your chart.
Excuse me, do you have also a safety rope, like we can say, like if I'm giving example of rope access, like when people are trying to clean the high-rise building, they have working rope, they have safety rope. So do we have same system in cranes also? Like if one working rope will break, safety rope will just at least help in rescue process?
No, there's no other safety rope. You can imagine on a crane, if you're using the main hook, there may be 8, 4, 5, how many returns, falls of rope. If one of them breaks, they all break. If you're on the auxiliary hook, one of them breaks, everything breaks. That is why cranes aren't designed for lifting people. There's no backup. I mean, there's no way you could have another rope fitted to another drum. That you wouldn't get that in a crane.
So it means working through the rope access is more safer than working on a man platform or something like that, man basket?
It depends on what your risk is. I would say the man basket is safer if the rope has been checked and there's no breaks in the rope, and it's not going to come off. And the biggest thing I would have is the older cranes. I've seen the hook drop out of the hook block. Okay.
Okay.
So sometimes it might be a good idea as a backup. You may have seen this. Even though they're hooked to the crane, people take a small steel wire rope and hook it to the main shackle. And they hook that, they bypass the hook and hook it onto the block. So you've got a small 2-meter loop just for extra thing. If you've got one of those really old cranes, the hook in the swivel sometimes could drop out.
Hello?
Not if it's been.
Hello, hi, Brian, can you hear me?
Checked and inspected and everything's been safe working load, but that's if you want with a mobile crane. If the rope, so if roped access is probably the safest way. Okay. So
We lost
sure
you. We lost your sound in the middle, actually. If you could repeat this point.
Okay. I was talking about there's no backup systems on a crane. If the rope breaks, it's coming down. Okay. The only system you can give is bypassing the hook, which will, in case the hook swivels off, you'll basically the man basket and bypass the hook and hook it onto the hook block, or onto you can actually get a shackle and put it on one of the falls of the rope, and it will hold that. I've seen that on a few times. People do that. It's not best, but that's all we have. If you're going to be doing a roped access method, I'd be asking why the crane doesn't have a BMU, the building doesn't have a BMU fitted, like a cradle. I'd be putting a cradle system up off the building rather than putting people in a man basket. The cradle system would have ropes drop down. So if you're on a 40-story building, I would go up to the roof, install a cradle, and have all my ropes drop down. That's the safest way to work.
I mean, there are some buildings which are having a design limitations. I mean, like they are looking really, presentable from the look, but installing a cradle and all those things sometimes become impossible on those designs.
Yes, I understand that. So I would be asking, you wouldn't get away with that in Britain because it's all down to CDM, construction design management. Now you have to build the building, you also have to clean it and maintain it and build it. And if you've got these reverse facing slopes, then you need, some of these BMUs come down, they come down vertically, and then when it starts to overhang, they actually turn and rotate and give you a rotating space. A lot of these buildings here in Riyadh on a project that just came off with these various architectural features. And we had a man basket designed that actually cantilevered out. So you could actually slide out the sides to get the overhang up to 2 meters and on either side. But then you have this payoff with counterweights. If you go out that way, it becomes a fine balancing act. But these people have been working on man baskets every day for 2 years because the BMUs were late in getting commissioned. Okay.
Thank you. Thank you.
But if you can get a cradle, put it in.
Mr. Brad?
Yep.
Yeah, someone is asking for questions so far. I think you are not able to hear his voice.
Hi, Brian, Srinath here.
Yeah, Mr. Srinath, I think he's asking 2 questions. I think.
I'm sorry, I can't hear you. Can you check your mic volume?
Volume. Am I now?
Hello?
Hello, am I loud and clear now?
No, I can't hear you. Go ahead.
How about now? Can you hear me?
No, it's really faint.
Alternatively, maybe he can write it.
Sorry, I was driving. My question is that as per the BS 7121 Part 3 2017, there is one more additional requirements for man riding on a mobile crane. It says that there shall be means provided with the mobile crane for providing safe access for the occupants of the basket in the event of a control and a power failure. So I have seen only one crane so far with that. Is there anybody with a similar experience on working on such cranes?
Malavan, could you relay that to me? I can't even hear it.
No, I have the same problem. Srinath, can you type what you said so we can pick it up?
Can you WhatsApp you?
Yeah, it'll be the same.
I don't know what happened. I'm actually driving with my Bluetooth on. I'm not able to text now, but okay. Anyway, I will personally message to Mr. Madhavan later.
Yeah, sure, Srinath. Yes, thanks. Srinath.
What I understood from his
careful,
conversation was, what I understood from his conversation was he's trying to talk about some feature that he has seen in one of the crane, but he can't find it in rest of the other crane, and he's asking about the experience of rest of us, that have we found any crane like that, something like that. I'm not getting the idea of that feature.
No, it's not about a feature. It's basically the standard requirement. BS 7121 Part 3 2017 and 2019 requires mobile cranes to have means fitted with it to provide safe access for the occupants of the man basket in the event of a power and control failure. It's similar to our emergency lowering in a MUP.
So it's a rescue process he's talking about, that safe access to
Exactly,
man.
exactly. Yeah, exactly. He mentioned that.
Brad, did you get it?
No, could you just relay that
Okay.
to me? I'm talking
Brad,
about.
it's all right. To be fair by the others, Srinath, just type the question to me so I can try to relay this to the others, because
Okay.
your audio is very low, and I would like Brad to answer since he's taking care of the session. Brad, let's move forward. We are out of time.
Oh, it's okay. Time's no problem for me if the others have to get away. Okay. Look, man baskets can only be used to carry personnel if they have been properly designed to BS 14502 Part 1, and that's 2019. There's a 2010 edition out, but that's free. You might have to buy the 2019 one, or your engineering company. But basically, I'll show you some pictures later of what we need to go through. You've basically had to have a recent test and examination certificate issued within 6 months. Now the door has to open inwards and it has to be latched to close. Generally you buy them now and they spring close and the latch closes and it's like positively locked. And they clearly marked with a safe working load and on a plate with the maximum number of people to be carried. It will say SWL 500 kgs, 4 packs, 4 people, 2 packs, three. That's 2 workers and a rigger or a signaler. Ideally, which is on my Christmas wish list, that they have a storage system for tools to contain in the event of a basket tipping. And sometimes a crane will get wrapped up on something when it's being lowered and it'll tip maybe 10, 15 degrees. That's one of the problems. But I wouldn't expect to see them in Qatar. Anchor points designed for fall restraint lanyards sufficient to carry the load of the personnel. It's best not to have the anchor point on the handrail, because if you fall out, you're going to fall out on a 2-meter fall restraint lanyard. You're going to be 2 meters out of the man basket. It's best to either have them on the ceiling where you can snap link to them, or on the floor. And there should be one for every person. If you see a central one in the middle, it'll cause people to get wrapped up in a maypole. And have been inspected before and after every use by the crane supervisor on any damage. Sometimes these things bash into buildings. They spin round when they get under control. So it's best to maybe look at that. And I'll show you next. Basically, every day you get in, you need to inspect it. And before lowering, if you're lowering into an excavation or a hole, do a trial lower first, because you might run out of rope. Some tower cranes are only designed for an extra amount of rope, and they might run out, or they might be on the limit. You may be putting a 50-meter deep shaft in with a man basket and find out the crane's only been designed to go down 40 meters below ground. It has happened. And then the rope's hanging there off the on the end of the drum. Having in place a means of communication between the operator and personnel in the man basket. So if you want to use hand signals and you're only 10 meters off the ground, 5 meters off the ground, and you're on a small little 50-ton Kato and you're working away and everybody can see each other, fine. If you're up in the air, need a radio. Now, big one, a rescue system needs to be in place in the event of a crane breakdown or emergency. Now, I've just come off a project for 2 years. And over that time, I'd say the tower cranes break down the most because they're not very maintained. Mobile cranes, not so much. But when the man basket was like 30, 40 floors up and the crane broke down at 6 o'clock in the evening, and it was a very hot summer's night in August, the only way out was they were just about half an hour away from breaking a window at 30, 40 floors up to get out of the man basket, because they reckoned it was going to take 4 to 5 hours to fix it. Luckily, they got it fixed and the crane lowered. But these people had gone up with no water, no rescue plan. Now, if they'd had a rescue plan, they would have had a rope for the, over the edge from the cradles, and they would have been able to snag onto that and lower themselves down. So you really need that in place before any lifting goes up. I mean, if you're 5 to 10 meters up and you can rescue them out of a MUP, fine. Then why didn't you use the MUP in the first place? This is where it all comes down. If you want to push back on your construction people, this is the best way, because there are ways around it. You can say my rescue plan is I'm going to call 999 and fire. Civil defense will come out and rescue them. That's great. As long as you write it down and your project management team approve it, crack on. But it doesn't work in UK. Now inspect all the crane, lifting gear, and the man basket before use, and test the crane's motion cutouts prior to use. So if you've got, make sure that all the cutouts work. Now, next one. Okay. Measures to prevent the man basket from spinning. If you're just off the ground, 10 meters, tag lines. If you're going up quite high up the building, get it close to the building so that it actually is pretty line 10 meters from the base of the, it's like a child with a balloon. There's nothing on the 10 meters out is not going to control it from spinning. What happened there? I just got a scrolly line go across my thing. Okay. The wind speed should not exceed 7 meters a second or 25 kilometers an hour. This is in the British standards, and that's for safety reasons. That don't exceed that. If you wind forecast says it's coming up, you may get 7 meters a second on the head of the crane, but it's at the work face. So if your crane's windy above and you're sheltered and you're lifting, you've got an anemometer in the man basket, and you're getting 5 meters a second, carry on. If you're working next to a building, you may have what's called the windward face and the leeward face. You'll be in shelter as the wind goes around the building. But on the sides, it will be faster. So it all depends on where you are with the wind. Okay. And crane operators not to leave the controls. Now, sometimes they just hang in a basket for 4 hours. The guy decides to get up, go to the bathroom, come back, go to lunch, and come back. It's had to happen to me a few times. And it's a pretty serious near miss when that comes up. Okay. No other lifts to be made on the hoist line. Some of these cranes have a main hook and an auxiliary hook. You're not supposed to be lifting 2 things at the same time. Okay, only one load on the crane. If you need another load brought in, bring it in with another crane. Okay. The crane does not travel while it's with a suspended man basket. Makes sense to us, but some people do it. I can just see that thing swiveling around. All personnel in the man basket must wear suitable harnesses and lanyards. I personally recommend a fall restraint, but there may be work that you need to consult your HSE team for, and they may say you need the shock ones or you need a 6 meter fall arrest. I like to keep people in the basket. There's nothing worse than having somebody hanging 4 meters out of a basket, 5 meters dangling off the bottom of the basket because they fell out. Man basket personnel should keep all the parts of their bodies inside the confines of the basket. When it's going up, a properly designed man basket should have a handrail inside to keep you so you can hold up, stand up, and you shouldn't be having to put your hands on the outside rail at all, because nothing worse than it hits the building, hits an object, crushes your fingers, takes your arm off. Okay, only the floor of the man basket is to be used for standing work. I've seen people standing on the handrail, just trying to get that extra little bit up against the building. Just take the crane up. No reason to be standing on the handrail. Keep electrical and pneumatic hoses from getting tangled and stretching and ripping, because sometimes you'll be going up with a compressor hose and you're not paying it out, or they're not paying it out, and it snaps, or the electrical cables get tangled up and break. And if you're welding, make sure that there's no stray current passes back through the man basket to the hook, to the steel wire rope, back down to the crane and the engine. There's nothing worse than that getting into the crane and shorting one of the controls out or earthing somebody. Okay. And then the final one, here's some man baskets I would recommend. This is a Boscaro, and it's purposely made in Italy. Has a roof, has all the things, and even the roof is demountable, so you can actually lift it without a roof. And there's where you hook your harnesses. I believe this is a 3 or a 4 man. This is one of the purpose-built ones we had on site. It's basically just a large cage with a small demolition netting roof. This was basically used for the cladding people for about a year. Very lightweight and just for installing panels. This is one of the ones that was made in country. Now you notice that it's got proper welding lifting points, and they've put polystyrene around the corners to stop it breaking and denting the facade material. Now, this one is improperly fitted. Can anybody tell me what's wrong with this rigging system here on the man basket? Anybody?
I can see these pad eyes are not diagonally opposite. It's straight pad eyes.
No, that's not it. Pad eyes don't need to be diagonally opposite because it'll come out with the, this is a purpose, this is a proper designed and engineered man basket from Italy. So have a look at the rigging gear and have a look at the chains and the shackles. There's something very key with a man basket.
The top picture has screw pin shackles, which is not acceptable. Should be 4-part shackles.
Yep. And what else? What else? I'll give you a hint. All the lifting gear, if you look at the bottom one is held on with a bolted shackle.
Yeah.
And it's onto a proper chain connection. So if you can see here, this is a 4-leg chain sling onto a normal screw pin shackle. So what's got to happen with a man basket is when you supply it to site, the lifting gear is dedicated to that man basket. It doesn't go anywhere else. And it can't be removed unless by mechanical means. So that's why we say bolted shackle and this special connection point here. This, when it goes away, it's all part of the same third-party certificate. This lifting gear does not come off this man basket. Doesn't get used for this one. Could be lifting pipes and rebar, and then somebody just puts a shackle on and up they go. This could easily work loose, and we don't know where this lifting gear is being. This whole system on the bottom one is dedicated to the man basket. That's a very important point. And the chain has to be able to take, there's factors for chain and steel wire rope of 8 times and 10 times for safe working load. So there's even a set size for the chain and steel wire rope. You'll get that in the British Standard 140502. There's a complete walk you through everything to do to get a man basket made in Qatar. Okay, we're getting up to loads with exceptional hazards. This is a very quick one. This is when you're working near a chemical or an oil and gas plant. Has anybody worked at Qatar Petroleum? Done a shutdown? No. Basically, there's a lot of risks working over live plant, live factory systems. So what they generally do is do a shutdown, and then they take major components out. Or if it's a power plant, they'll de-energize some electrical part of it, or pressurized systems, they'll just depressurize them. Each client has their own specific requirements, procedures, and processes. You may even find like Qatar Petroleum has their own lifting procedures. They have permits to work, permits to lift, and they even have Qatar Petroleum have their own specialized and approved lifting training qualifications. Now, if you ever find yourself up in Qatar, and you'll see on the back of the third-party certificates, there's a thing that says spark arresters. That's a Qatar Petroleum must for not causing explosions. Also, when cranes are working over certain areas, they have to have slew restrictors and zoning. So sometimes the tower cranes can't lift over an area. They will be physically locked out by the software in the crane. It'll stop them from arcing or slewing over something. Now, restriction on the use of certain types of lifting gear. Maybe they don't want you to use fabric web slings because the chemicals or the heat is corrosive, and they could endless slings. A lot of I'm hearing, I've never experienced, but I don't think they like those endless slings. I don't even think I've seen them used too much here in Qatar. People prefer just the fabric web slings or chains. Any questions on that one? This is a very quick one. There's some pipe work going in, components into a live facility. This is a topping and tailing that went wrong and is getting recovered. And this is some sort of pressure vessel going in the side of a nuclear facility. It's getting slid in. They're just examples. Last one, and these are when we get on to the what's called the American OSHA critical lifting, exceeding 75% of the chart capacity. Now, if you've ever had to look at a lift plan, you'll notice that in the top right corner, there's a little sticker just above the load chart. It says ISO, DIN, EN, and it'll look like one of these, DIN, ISO, DIN, EN, ISO. Now, this means the chart complies with ISO 5019.2, and it's generally headed with a 75% figure. And sometimes you may see the 85. That's in countries like, I believe, the Netherlands, and a few European countries use that. If in any doubt, just make sure you've got the 75% chart. If this load chart value is reached, then the crane's audible warning system starts. So there's an internal warning at 75, and then it goes a bit higher, and then it becomes external. But you're still at 75%. You're at 75% of the crane's tipping load. Now the crane has been tested on that chart load plus another 25%. So the crane has been structurally tested almost up to tipping load, but not quite. So this crane is structurally capable. Now, the OSHA 75% limit, and it's generally a project requirement. I'm finding it in the project management safety plans. And if you work to that, they've put that as a blanket statement to cover all lifts so that you don't have to think about it. You don't have to say, oh, it's 2 ton, it turned out to be 3 ton. It basically accepts that people don't do very good lift planning. But if you do very good lift planning and you know that nobody can lift more than a 2 ton bundle of rebar, or a shutter cannot weigh more than a ton, and the hook block weighs so much, you can manage this. This is still a project requirement, and you can manage your lifts, but it's a waste on the economics of the crane. Can you imagine you're throwing away 33%, okay? If you got 75% of a 75% chart, you're at 56% of okay? So you have a 5% at 100%. You scoped it out, whatever you're, I'm just letting you know that if it's not on your project requirements, don't just put this in. If you're working to British standards, all your lifts need to be planned. And this is what I was alluding to earlier, that this 75% limit is just a factor of safety. It means nothing to the people writing it, but it's an economical, I mean, if your people are trying to save money, this is where to go. Okay, the crane capacities could be 75-ton cranes, could be used a 50-ton crane. But you need to know that if you're going into that last 25% on the chart capacity, you need to know accurate weights and loads of your rigging. You can either do this by calculation, or every time you pick something up, write it down, and you'll eventually get a schedule of lifts, and you'll be able to say, that generator weighs 4 tons. Write it on the side of it. That's what I do. Go on a big marker pen every time I lift it, and I put the hook, take the hook block off, and I say, that generator weighs 4.3 ton, done. And I put it in my schedule of lifts, and next time I go and lift it, I know exactly where I can put it. If you're going into that zone, do a reevaluation of the ground bearing pressure and outrigger pad sizes, because maybe you putting more pressure on the ground than it was tested for. know the maximum operating wind speed of the crane. Mobiles, generally around 9, tower cranes, a bit more, maybe 13, depending on the make. And tower cranes, you can go up to 20 meters per second. I know, again, your PMCMs will write in your project requirements that the crane cannot work past a certain figure, but it's based on the individual. It also says next to that, based on the manufacturer's requirements. It's very hard to control a crane above 15 meters a second, believe you me. And that's just lifting rebar. I mean, there's too much shake on the crane to control the load. Depending on the wind area of the load, now somebody was talking about this way back, the surface area of the load it could have a sail effect. Now you need to go back and subtract that from the maximum operating wind speed. So you may find that the crane can lift in that zone, but you can only lift at 6-7 meters a second. And if this is the case, then the wind speed during the lift needs to be monitored with an anemometer. And if expected to be exceeded,
Brad, there's a question.
from the weather forecast and the question?
Brad, there's a question.
Yeah.
Can you accept?
Yeah, sure.
Yeah, Anand, go ahead. I can read out the question, Brad.
Sure.
What he's asking is, can the crane be used at an angle of 5 degrees to lift any sort of load?
Well, the outrigger pads and set up, the crane set up 5 degrees off horizontal.
No idea. Another, do you think you can unmute your mic and ask your question?
Hello.
Yeah.
Actually, I have encountered a situation in my site. So they were using the crane at an angle of 5 degree with crane outrigger pads, everything is set. So as per when I saw this, I thought it is unsafe. So is it unsafe to use crane like that?
Yes, it is, because you're actually changing the center of the gravity of the crane. If you can imagine, if the outrigger pads, the crane's got these leveling functions on it. Obviously, they've set up on a slope, and they need to build the ground up on one side, because the outrigger pads, there is some tolerance, maybe like 0.5 meter. You can put the rams down and level the crane up. That's why they say you need to level the crane up. And the reason I say it's unsafe is you've moved the center of gravity towards the slope. It's actually in, there's a Syria series I'll give, it shows you when you set the crane up, if it's out of, it puts the center of gravity to the high side. Does that make sense? It moves the center of gravity, not by much, but it changes that. And if your safety people see that, they should be, that's the first thing, the crane must be leveled up. I've seen me packing up my outrigger pads with grillages and timber, and I've had to go out and get the construction people to pour concrete. I've set up on slopes, but you basically have to make it so that when the crane finally gets into position, it's perfectly level and all the outriggers are at the right length, and yeah, perfectly level XY. Does that make sense?
One more question from Yana Xavier. Yana Xavier, can you go ahead?
Hello, good evening, sir.
Good evening, please go ahead.
Yeah, I have a question. I want to know if we have, let's say we have a load chart of a 50-ton crane, and it says that at a radius or a distance of 3 meters, the crane can actually carry 50 tons. I want to know if that can actually be practicable, and how can that be? Because I haven't done that anyway.
That's basically how they come up with the capacity or the name for the crane. It will lift 50 ton at 3 meters. Now, 3 meters is basically between the outriggers on the side, because the end of the crane on most cranes is 3 meters away. So if you were lifting on the left side, a 50-ton load 3 meters away, your boom would have to be almost vertical, and the load would have to be right next to the crane. But that's just to give the crane, it can do it, but what's the purpose? You wouldn't be able to put it anywhere. You couldn't even take it out with the outriggers. That's, so if somebody said to you, it's a 200-ton crane, it will lift 200 ton at 3 meters. But the end of the crane, outriggers, and the tail end of the crane is 3 meters away from the radius point. So you can only lift it off the side. Does that help?
Yeah, thanks very much. I have another question regarding the ground bearing pressures or capacity.
Yeah.
You know, we have challenge in our companies whereby we don't even have like geotechnical engineers probably to check the ground bearing capacity. Most of the time we move on with compaction. And I just want to check with you if there could be a way that you can actually guide me on how I can proceed to make sure that without even passing through geotechnical studies, because our company does not have it, but they just want the job to be done. How can we do it? How can we actually proceed? We have rollers, we have backfilling materials they can compact, and I don't know, because sometimes I do get confused.
No, it's a valid point. If you're making ground up and you've rolled the ground with method compaction with a large roller, and you've got it to, when your QA people come out and say it's 90% of density or something like that, you should be able to go to your civil engineer and say, what is the maximum load I can put on there? Because you've already proof rolled the ground with this roller, and he will give you a value, okay? Does that make sense? You should actually have in your company a temporary works engineer to look after concrete pours, shuttering, scaffolding design, anything over 3-4 meters needs a temporary works people. Do you have that person in your company?
We do, we have.
Well, I would go to your temporary works engineer and tell him to say, hey, we're proof rolling this material out there to whatever the spec says, 80%, 90% of dry density. What is the maximum ground bearing pressure per meter squared? They will work in factors called kilonewtons or kilopascals. Give you an idea, I've tried to take virgin ground in Qatar, somewhere up the Green Line years ago, and I did 9 sites, and I filled up a 40-ton articulated truck with rocks and did a plate load test, and I did it on every one of my sites in 4 or 5 locations to get a spread. And my test failed at 200 tons, in excess of 200 tons a meter squared. And the reason it failed is because the load wasn't heavy enough. So when the load lifts the truck off the ground and the jack doesn't go into the ground, the test stops. I didn't have a heavy enough reaction load, but I took that figure and just called it, for ease of sake, 100 tons a meter squared. And that was my figure for all 9 sites. And we never had a failure. But if you're on made ground, it's a very simple calculation for your temporary works person to figure it out. You don't need to look at the geotechnical, because the geotechnical was done before the site got built. If you're backfilling, it's whatever the specification for that ground is. You'll take this Dynapack roller and 6 passes at 150 mil air, and over all that buildup, you should have a very safe ground bearing pressure in that specific area. Okay.
Thank you very much.
One more question from Ranish.
Yep.
Ranish, go ahead.
Yes, related to this ground bearing pressure, when we calculate for the mobile cranes, we calculate 75% of the total crane load or crane weight, including the counterweight, plus the dynamic load on the hook, divided by the the outrigger pad sizes. That's how we arrive the actual ground bearing acting on each outrigger pad or each jack. So in case of crawler crane, how do we calculate the actual ground bearing acting on the crane, or how we can confirm that the yeah. Sorry.
Right. With the crawler crane, the larger ones, the Terex or Terex has a system like that. And what you've got to look at is the actual footprint of the track. Now, like a large crawler crane, like a Terex, might be 9 meter long track and 1.5 meters wide. Each track is like 13.5 square meters. Okay, so the whole crane, and then it's a way of doing math. Now, if you lift over the front of the crane or the rear of the crane, you have this triangle starting at the back at the surface and drives down to where the load is at the very tip of the tracks. Now, it's easier when you're lifting over the side of the crane because you can say then that this one track is taking 75% of the load over 13.5 square meters, and the other one's only taking 25. So it's if you Google it, you'll see these little drawings, and they'll show you these like little wedge shapes going into the ground. And it basically, one of your geotechnical guys will be able to help you with that. But it's the all-up weight of the crawler crane, 75% of that, with the counterweights and the what's the word I'm looking for? The superlift and everything. When you start putting superlift on, you should have some calculations for that.
Okay, so that should come from the crane manufacturer, you mean to say.
Yeah, and in fact, for a mobile crane, the 75% figure is way out. If you can spend the time and get the Lycon software, you'll probably find it's only 40% in the region, 30-40% of the rig weight of the crane. Don't quote me on that because it changes. It's not 75% is based on the crane fully boomed out, fully loaded, like a maximum fulcrum. Whereas if you plug all the details into the Lycon software, each radius generates a different ground bearing pressure because the load's further away or closer. So, you know, you tell it's going to lift 10 ton and you're going to take about 30 meters, it will give you the maximum ground bearing pressure over one outrigger, which is what you want. And the figures are always dramatically less than 75%. 75% is overkill, but unless you've got some sensor nodes, I think most of the cranes now, they have this software, and the reps will come out, or the supplier, if they bought a crane within the last 5 years, should have been given the software. Then they give you a nice little printout to say this is going to generate 45 tons on this outrigger.
Yeah.
Leaving lever and Chinese cranes, most of other manufacturers have got a free website to calculate ground bearing pressure.
Yeah, I was just going to go there. You just reminded me that the companies like XCMG and Zoomline are all onto that now.
Yeah, XCMG, all these Chinese manufacturers and lever. Lever only gives the software when you purchase model. Chinese, I don't have an idea, but other manufacturers like
Lever's got a website. If you Google Lever Lycon,
they have a free website to work on.
Yeah. I've seen people here in Riyadh show up with a Terex and all sorts of stuff. So I know everybody's in the last 4 or 5 years has come out with these ground bearing pressure models.
Thanks, Brad. I will look into that.
Brad, shall we proceed?
Yeah. So our next one on blind lifting. Most common safety incidents associated with blind lifting related to poor communication. Nobody understands where the load path is and it becomes blind, and lack of understanding of the blind zone. When they set the crane up, they can't see over the edge of the excavation. They don't know about layout, exclusion zones, control place. So control measures you need to consider are communication method between all members of the lifting team. And at least one slinger signal needs to see the load throughout the entire lifting operation. Doesn't matter if the operator's blind or the people receiving it are just see it coming in. One guy needs to see both sides of the wall or both sides of the pit. Sometimes the noise is a problem. Like it might be a lot of really noisy works going on, jackhammering or whatever. You may not be able to communicate. But so one of the things that when you're talking to an operator and you're telling him to go down, 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 if you just keep talking to him every second or so, and he doesn't hear you for 2 seconds, then the operator, you need to get him to stop, just completely stop. If he loses contact with the slinger, and then you reestablish it once you get communication back. Make sure you got radio batteries and you got spares, and they're fully charged up. And when you're picking up, make sure if you're picking up blind that the hook is central over the load, okay? Maybe drop yourself a plumb bob or a sling or something off the hook to see where the center is. Because if you pick that thing up 4 inches off the ground, it's going to shift to the center of the hook and probably crush somebody. Because blind lifts are generally into buildings and shafts, and that's not really a good place to be when you're picking up a load in a tight space and it shifts. So this one here is just a diagram to say there's a crawler crane, and you can see the gray triangle here. The operator can't see that. So that whole area is his blind zone. Now, if you've got like an excavation here and you've got like shelving or benching, or you've got some like a structure, and some rigger can actually position himself to see the operator and the load here, that's where he wants to be, okay? You'll see it on site. Every blind lift will be different. You don't want to know where it's going, where the crane is, and then you need to get the team to walk around in the middle and see if somebody can see all of it. Okay, so there we are, we're finished.
Excuse me, regarding the what you call the center of gravity for lifting operation upward and the downward into the excavation. So how much will be a difference in there? Like, I mean, which will be more risky with the same specification of crane?
Sorry, the center of gravity. Could you go back to that?
Yeah, what I'm trying to understand is like, I mean, when we are lifting some weight and trying to lower it either on a ground level or inside the excavation.
Yeah.
So what my thought is like, I mean, if it's going more lower into the, same picture as you have shown in a second last slide. So 44 meter deep. So in that situation, obviously the center of gravity is shifting toward the load's direction, and there is a more chance of crane tipping over toward that side.
No, the rule of thumb is once you go below ground level with a crane, you start adding on the weight of the rope. Does everybody know that? The crane is designed to be picking up on a level surface. So everything is actually factored in with, so from the hook block you would add on. But if you went below ground, you would say, oh, I've got 6 falls of 44 meters with a, I don't know, 15 mil rope. So I have to add that weight onto my load. That would be an extra load you would consider for that case. If anybody's worked on any of the metros with the tower cranes, they would have done that, or with the center of gravity is always the same. It doesn't change. So if you're lifting a load and you haven't, say the center of gravity is eccentric and you lift it up with 4 slings that are the same length, it will actually it will stay, the center of gravity will always be under the hook, but the load will not sit level. It will be one side will be lower than the other. So when you lower it, it will just be lowered. It will pick off the ground. One side will come up first, and then it will actually swing to the center of gravity underneath the hook. That will be your first movement. And when you put it down, the one end will be lower and that will drop down. It's best.
I mean, the center of gravity for the weight will be same, that I can understand. But the thing is, if you look at the complete system, like the crane, as well as the weight and the complete mechanism that we are having there. So the center of gravity of the whole system will shift. That's what my thought is. When the elevation is going outward, you can say when the wind is blowing, when the weight, is lowered. So this change in the, the complete system might shift the center of gravity for the whole mechanism.
No, and there's generally no problems with it with the center of gravity of the crane once that's fixed. I mean, you're within the operating speed of the crane with the wind speed. I mean, unless you've got a very large sail area and you're very close to the tipping load of the crane, and even with the chart value at 75% of tipping load, you will never go over. The only way you would go over in that situation and change the center of gravity was if you exceeded the 75% on the chart capacity and had a very high crosswind blowing you out of radius, which, you would be above the 9.8 meters per second or whatever the maximum operating speed of the crane is. You wouldn't affect that animal, really. Maybe a small 25-ton Cato crane lifting a large piece of plywood shuttering, and he's at the limit and a wind came up, that might tip over. But a large crawler crane with superlift putting a cutter wheel into the ground, these cutter heads weigh about 60 ton, and they've got a surface area, but the amount of wind pressure you would need to move that would be maybe a gale force wind, even try and move it a couple of inches off vertical. It's a very dense, it's all about load density. If you've got a very light load, then you get a sail effect, like a plywood shutter, very large surface area, very low weight. But a cutting wheel made out of, tungsten steel and everything else, just, big chunk of cast iron weighing, I don't know, I think it's like what's a cubic meter of steel weighing? 7,000 kilos, 7.8 kilos, 7.8 tons per a cubic meter of steel. So that cutter wheel's going to weigh quite a lot, and it's quite dense, whereas wood weighs half a cubic meter of wood weighs maybe 300 kilos. Do you get my point?
Yeah, density of each and every item is different. Yeah, you're right.
Low density?
Yeah.
Brad,
Thank
we
you.
can accept 2 questions and then we can wind up. Or we need to provide dinner for everyone.
Yeah.
Okay, I have a question, please.
Yeah.
Yeah. What I want to ask, is it a safe practice to use a mobile crane to use both the main hook and the auxiliary hook to lift something or to twist something around? Because I remember seeing an operator with a mobile crane. He, I don't know how he did it, but based on his intellectual skills, he was able to use the auxiliary hook, and as well as the main hook, he grabbed an object and he was able to twist it upside down like that. And I saw it, and I don't know if it's a good practice.
It's probably not, because we get back to the hoist ropes need to be vertical. I've seen it done. Now, this is with a large crawler crane, and we were lifting pile cages into the ground. Now they would pick up the pile cage on the halfway point and move it to the side of the pile cage, and then they would, at the same time, they would turn the pile cage using the auxiliary and the main hook. I've seen that happen because the operator can do that, but you need to look at the forces involved, because as soon as you take those ropes out of vertical, you're actually putting forces and stresses on the crane jib. Some of these operators think it's their party trick to do that. I would, if it's a lateral loading, then you have a problem. If you could draw it out and try and see how it did, but I've only seen it done with pile cages, and that's stuff from the dewatering or the foundation companies.
Okay. One more question. Mohammed Subair, do you want to ask? Mohammed Subair? I think probably click back.
Hello, Mr. Malavin. Can I ask a question?
Yeah, okay, please go ahead.
Yeah. Mr. Bird, please, this question I'm going to ask is concerning rigging configuration. Is it safe to lift a crane using the extended outrigger? Is it safe? Let's assume the crane manufacturer has not designed any lifting points with that crane. Can we use the extended outrigger as our lifting points?
You want to pick a crane, you want to lift a crane with another crane?
Yes, with another crane.
No, because
okay, in a situation where the manufacturer has not designed any lifting points on the cranes, what do we do in that situation?
He's not provided any lifting points.
Yeah, on the crane.
Okay, well, I would actually be designing myself some beams to go between the axles and take up underneath the load, just underneath the tires. I would try and make some sort of cradle and then lift the crane that way off the tires.
Okay.
Based on the principle that the down pressure is equal to the up pressure when you pick it up. But I definitely wouldn't lift off the outriggers unless the crane manufacturer says it's okay. What kind of crane are you trying to lift?
No, not really. It's not really. I saw it on the LinkedIn whereby somebody shared a lifting operation which he has supervised, and people had different comments. It is safe, it is not safe, and I said, okay, one day I'm going to ask this maybe when we meet or ask you like that. So I just had that opportunity to ask you now.
Okay.
I saw it on LinkedIn.
Well, think of it like you're pushing down. Put your arms on the table at your sides, and you're trying to do a push-up. And then somebody comes along and is like lifting your elbows up, and you're going the wrong way. Do you see what I mean? It's like horses are going the wrong way. And you've actually, by extending the outriggers, you formed a larger moment for that thing to rip off. I wouldn't do it unless the manufacturer said it was okay. You could probably find lifting points. The crane should have a center of gravity. I've got a picture somewhere that I took of a small 8-ton crane being lowered into a shaft or into an excavation about 6-7 years ago. I think it had lifting points because it was that small, a very small crane. It was an 8-ton mobile. I've never seen one that small. It wasn't a spider crane either. Let me turn this off. Stop share. There. Yeah.
Okay.
Anybody else got anything? I don't mind.
Last question.
Hello, sir.
Zana Xavier.
Hello, sir.
Hi.
Sir, I just want to use this opportunity to understand this question. I went somewhere and I was actually embarrassed. The interviewer asked me like, okay, as an appointed person, what do we have to do in case of high wind using a tower crane? And he went further saying that you can find it anywhere, you can get it. Those are the basic you should even know. So I was like embarrassed because to me, it was very strange to me. So I did not even have the courage at the end of the day to ask him like, okay, sir, sorry, I don't know. Could you tell me? So I just want to know from you, what are the things we have to do, an appointed person has to do, maybe an instruction he has to give to the crane operator, the tower crane operator, when it comes to high wind speed?
Well, I know from a fact in Qatar, they used to limit my cranes at like this blanket speed. I can't remember what it was, but it wasn't up to manufacturer speed. Now the crane technically can work up to 20 meters per second. That's very fast. But if you can imagine trying to control the load with the crane bobbing around and the load goes into this pendulum effect. So I think I limited it at 12 meters per second. and that was for lifting rebar. And I had the project was delayed, and I said to them, well, you can go up to 15, but you will slow yourself down because of the difficulty in controlling the load. And this is for very dense things like bundles of rebar that weighed 2-3 ton, had a very small surface area. What I generally do is I give the crane operators a table, and I say, when you're lifting shutters, I cap that at 6 meters a second because it has a large sail effect. And 6 meters a second can be handled by the crane. It will buffet the crane around a bit, but the people holding the tag lines, if they get it wrong, the crane will spin them off their feet because of the surface area. So somewhere between 6 meters a second, and if you can imagine, your mobile cranes have a cutoff at 9 point, whatever the manufacturer says, 9.9. And if you can say the crawler cranes can go up to 13 meters a second, and the tower cranes can go up to 15 to 20. But then you have to say the maximum you could lift that load is 6 meters a second across everywhere. Plywood, 6 meters a second. Rebar up to the maximum speed on the crawler crane and the mobile crane, but on the tower crane, don't go any more than 15. So there's a table that you should make up based on your experience on site. Some things you can't even land. You may find that with a tower crane that the guys working on the ground are very stable and they're in a sheltered area, but the head of the crane will be bobbing around with the operator trying to control it. Once you get above 15 meters a second, it's best to stand the cranes down, the tower cranes down, and go into a free slew situation, unless you're finishing up one lift. If you've got one crane in still lifting, then the others have to have the brakes on to stop them slewing in if they're overlapping arcs. Is that?
So I'm talking a situation whereby the wind speed is very high.
Yeah.
And we have to suspend the lifting operation.
Yeah.
So then he was saying that there are basic things that an appointed person has to do, because I told him that we have to suspend the lifting operation in a very safe manner. Then he said, and he went further, and then he got angry. He got very angry. I was embarrassed that you're saying you're an appointed person, and those are the things you don't even know, you can find them anywhere. So I didn't, I'm just trying to get this clarification.
I would look for, depends on the cranes, I would look at British Standards 71211 Part 1, Part 3, and Part 5. And then I would look at some of the things that go with that. But once you reach your maximum speed for the crawler crane, say you get up to 13 meters a second, you suspend lifting operations. That crane now becomes out of service. What you need to do, and what happened in Mecca a few years ago, they parked the crawler crane up with the jib too high up in the air, and the wind blew against the jib and tipped the crane over, causing a large problem. We have problems here with luffing cranes. I don't see many luffing cranes in Qatar, but if you park the luffing crane at a certain angle, I think it's about 75 or 78, it's in the instructions for the tower crane. When you go into free slew and you wind the crane off, you have to leave the jib at a certain angle with just enough weight to counteract the wind. If you take the jib up too high, like 80 degrees, like vertical, the wind will come along and topple the crane. And mobile cranes, bring them down to the first section, bring everything in. So it's sitting on its outriggers, and you brought the jib in, and if you can, bring it and land it. If you want to leave it up, then you can leave it up to one section. Have a look at, like I say, 7121 Part 1. On Part 3 and Part 5. And it's the same with the crawler cranes as well. But when you wind a crane off, it's certain levels. You could wind a mobile crane off and still be working with a crawler crane nearby, because the wind at one end of the site might be different. You may be sheltered by a building. You may be sheltered by something else. So I ask it's 9 meters a second for mobile cranes, 13 meters a second for crawler cranes, and then I would go up to 50 meters a second for tower cranes lifting dense loads like rebar. I would actually specify the load, and I would give that to the crane operators and a little like matrix crane load. So if you're lifting like you don't want to be lifting shutters in more than 6 meters a second. It's hard to control. You can go back and look at the wind pressures developed even on a 4x8 sheet of plywood, and then you start multiplying them. 2.7 per sheet of plywood. Put 10 of them together, you got 27 square meters of sail area. Your riggers, your tagline men can't hold it. Okay, so it's all down to surface to weight ratio, like density. The more dense it is, you can go straight up to the load of the crane or the maximum wind speed. If I was lifting polystyrene blocks up and it had a high wind, they would be almost sitting horizontal to the crane.
Okay, thank you very much. The last question, please, before what are the, as an appointed person, because I'm talking based on my experience, I do not have experience when it comes to tower crane, because our company, we do not really work with tower cranes. So as an appointed person, what are the things I have to know when it comes to tower crane erection?
Tower crane erection depends whether they're going to put the whole thing up on a oneer or they're going to jump it. The main thing I would make sure, first of all, that the base is designed by a competent engineering temporary works people, and you've got all your moment reaction. You pass it back to the tower crane supplier, and he says, yes, that's okay, or no, it's not. If you're buying a Chinese one, they will actually give you the base diameter, width and height, and they give you the rebar. Setting the anchor bolts at the right location, the right height. Don't put the anchor bolts in too deep that you end up having to break out concrete. Best thing is to cast the anchor with the first mast section so you can plumb it up. When you pour your concrete, you've got a 5 meter section that you've verticaled up. I've seen people just put the stub in and try and vertical it up. And you can imagine over a 2 meter baseline, they're 1 mil out, 2 mil out, 5 mil out, which is easy. So you imagine that you're 5 mil out over 2 meters, and now you're going up 200 meters, you're 500 mil out. The crane's off vertical, okay? Just to give you an idea of how critical it is to get that first mast section cast and vertical. After that, you generally, if you're going to climb a crane, that's the easiest way. You would build the mast section up 3 or 4, and then you would put the head section on, and the climbing frame, head section, and you would build the crane, basically a small crane on the 2 or 3 mast sections up with a climbing frame on the side. Make sure you get the climbing frame in the right direction, because once it's on, the climbing frame is a 3-sided thing with a gate. If you get that wrong and you're 60 meters up in the air, 100 meters up in the air, it can be solved, but it's a major problem because the crane has to take its mast section out of the gate, and it needs to go, generally it goes parallel to the building. You don't want it going perpendicular to the building. You want it parallel to the building. You want to make sure that the tower crane is far enough away from the building that the jib or the counter jib is got enough room. Because it's great when tower crane's above the building and you want to strip it, but once you get down level to the building and you're not, the gate's in the wrong location, depending on where the site is developed a year, 2 years later, you may find that you can't strip the tower crane using the self-strip, and you have to actually get a very large mobile crane in and take the crane apart, okay? If you're jumping a crane, when the 3 or 4 mast sections go on, it's very easy. Once the crane's built, you don't need a third party or anything. The crane's building itself under its own power. You basically just make sure there's a support crane there feeding it with mast sections underneath the boom. And you could probably put a mast section in every hour and jump a crane if you're got a really good team. So if mast sections are 5 meters long, you could probably do 40 meters in height a day. And then you've got to do the bracing. If you're freestanding, you can take some of these Chinese cranes up to 60 to 80 meters high freestanding, but you need a massive base. But it's best to have it up against a building and then about every 40 meters, tie that into the structure. If you're operating a tower crane, the big thing to worry about is the hook is already part of the load. You don't have to worry about the hook. Everything below the hook in a tower crane is your load. So it's just the rigging and the load. And for the lift plan, the crane's in the same location. So you have the entire map of the tower crane and all your pickup points. So it's very simple. You do one drawing and that's it for 2 years. You have your pickup location on the road, and then everybody know, and then you have a series of arcs showing you the location of the next tower crane and where it fits. So you make a little map up, put that in your lift plan, do yourself a load schedule of 20, 30 loads, and forget about it. All you have to do then is worry about the third-party certificate for the crane every year, and the rigging gear every 6 months. But if you're going to lift a man basket, make sure it's in every 6 months. Tower cranes, if you're putting a mobile crane up for more than 3 months, tell your guys to start looking at mobile tower cranes, because you can imagine some cranes might, like a 100-ton crane, you get it in for a year, you could have got a tower crane in. It cost you more to put the base and the crane up, but the cost is only $20,000 a month, whereas a 100-ton crane will cost you more. And then if you're going to keep that crane there for 2 or 3 years, tower crane every time. It's faster and it's cheaper. You've got a startup cost and a stripping cost, but your electrics come from site. There's no diesel, there's no nothing. It just works. When you're putting a tower crane up, make sure you're not near the airport. And even if you are putting it up, make sure you let the Civil Aviation Authority know you're putting a tower crane up, because they'll put it on the map and you've got to give them the height, the jib length. And when it's fully up, make sure they put aviation lights on the top of the cat head, one on the counter jib and one on the very tip. And the Civil Aviation Authority will tell you what they need to be. If you're really close to an airport, they might need to be the white strobe lights. But if you're kind of like where we were up the Green Line and quite far out of Doha, they only need to be the medium intensity flashing red. But if you're quite close to Hamad Hospital and you're putting a tower crane up, you'd probably see them with a flashing strobe to warn the helicopters. So that's the only thing about a tower crane. You need to let the Civil Aviation Authority know as well. Just write them a letter and they'll write back. And they're not going to stop you. They just plug it into their ground model. Any more?
So is there any height requirement for which we have to inform the civil aviation, or for any?
There is, and it's in the ICAO volume 14. It depends on how far you are away from the airport and if you're on one of the flight approaches. So like the planes are taking off and they're going up and you're putting a 200-meter crane up. There's this kind of tapers that go out from the airport in all directions. They taper upwards, but even it's good. Anything over 10 meters, I would 10, 20 meters, I would inform them, just as a matter of safety. Because you
Thank
get a
you.
lot of crazy, medical helicopters flying around. It's not so much the people landing and taking off the airport, it's the people with helicopters and news teams and that fly into it at night. And what they do, once you give them the coordinates and the height, they will put that into what's called a notice to airmen or something, a NOTAM. And all the pilots in the area will get that update, this tower crane. Who's talking?
Subair, would you like to ask a question? Your hand is up.
Yeah, I would like to ask. The question I wanted to ask initially was about the wind. I think Mr. Brad has answered that.
Subair, there's a lot of background noise. I mean, I think someone's speaking near you.
Yeah, I'm sorry. I'm in the office. I'm on site working at night, so I had other people communicating on the background. Hello?
Okay.
Here he is. Good in the car park.
Hello?
Yep.
Yeah, Mr. Brian, I really want you to shed more light on the topic, the wind, about the wind, because mostly we're working out.
I think he lost the signal.
Yes, he did.
Did anybody get that? I could relay it back. I got frozen.
Brad, if you don't wind up, it's going to become an AP course, a mini AP course. Okay,
I will send you my thing out of my procedures for wind speeds. It's very easy it's just a generic loads and cranes and what you can lift at various things, and got reds and greens and yellows to let people know.
Perfect, sir.
Okay. So Brad, shall we?
Yeah.
So one more question, please. Please, I just want to use again this opportunity to what can you advise somebody like me to when it comes to the next course I can do? Because I'm certified, and I've been thinking to get something in alignment with what I'm doing. Thinking to go maybe for LEA inspection, or maybe is there any course related to critical, how is it called, like heavy lifting? Anything you can advise me on?
I don't know if there's any courses on heavy lifting in LEA. I know there's an appointed person course. There's rigor courses. The best way is to get a job with one of the big crane companies like Sirens or Mamoet, or somebody where you're exposed to it's almost like it's like they don't share the knowledge. They keep the knowledge in the company. It's very hard. But if you're good at math and you're good at understanding principles of physics, you shouldn't have a problem. If you understand the principle of gravity and pressures and forces, that's where a lot of people, like I can sit down and work out rigging tensions from first principles. I don't need to know the 1.4, 2.1. I can do it with the angles exactly. So that's kind of, if you get good at your math, it's like working out the ground bearing pressures for crawler cranes. You can do it from first principles, but you've got software now that numbs everybody's brains. What we do in construction is high density, multiple low weight lifts. Like you're lifting rebar in a 20-ton of rebar on a truck, 10 bundles. That's done, 10 bundles, 15 minutes or 10 minutes a bundle. Shutters, formwork. Whereas in oil and gas and heavy lifting, they set up for 2 weeks for one lift. They do the lift, they all stand around, they look really fat because they just eat. They got their hands in their pockets. and they watch the lift go in, and then that's done. And then in another 2 weeks, they get another lift. But in construction, where we are, anything up to 200-ton cranes, it's really fast, high output. And the only thing you can do is look at your turnaround times and go out and look at your rigging team and see where they can improve. Like when you're lifting rebar, instead of wrapping the slings around, get yourself a 2-meter endless chain, wrap it around once, pull it through and choke it, and then hook your hook onto it. You see what I mean? You can have that other next bundle already ready to go. So as soon as they've dropped it off, they're returning for another load. Look at the cycle times if you want to get better, because it's all about productivity in construction. But when you can take 10 loads, 4 loads an hour, one every 15 minutes, and get that down to 6 loads, that's almost like a 50% increase in efficiency. And that's where you want to be. Okay? I know the safety people will say it's ought to be done safe, but once you get out of the safety and your team's working safe, you should be striving for efficiencies.
It's very challenging, sir, because to get that privilege probably to join a company and you do not have experience on it becomes a serious problem. It becomes a serious problem because lifting is a life critical activity. So you need experience. So how can you join such big companies and when you have zero experience in what they are doing? It is a situation we are really facing daily. That's what I was thinking, like, what should I do? I'm LEA certified. I want to go probably for maybe LEA inspection to get the knowledge in terms of inspection, or I can see if there's anything in terms of heavy lifting. So
I think LEA, if you look at the LEA courses, I think once you get into inspection and that, then you're getting yourself into the third party and you're drifting away from construction. I really don't know. I've actually applied to MAMO a few times to be a project manager, my CV, and they don't even write me back. They don't even say, could you come for an interview? So what chance have I got? You know what I mean? I actually think it's a little secret club, and they just go around and they meet people in a bar and they talk and they go, oh yeah, you know so-and-so, and oh, you're in Angola on the rigs, blah, blah, blah. Next thing you know, this guy's got a job. I don't think all the jobs I've seen on MAMO over the last 5 years, sometimes I just apply for a laugh. And I've got last 8 years, 9 years have been almost pure lifting. And they don't even call me back. So I wish I could give you some advice.
Just a quick question. Sorry, just a quick question.
Let me finish this. If I was going to suggest anything, go and work for a reputable crane company that has a fleet up to 500 tons, like Sarens or Manai, and you get in there, and all these companies now, these bigger companies that are clued on, are taking their lifting vertical. They're actually supplying riggers, supervisors, and APs and managing the lifts. And they see it as a value added. They will actually do lift plans. I've had some clients here in Qatar or Saudi that have gone to Manai and companies like that, and they write lift plans. I think who's the big one down in Lusail that's got all the big cranes? They've got the big crawlers, CC280s and that 2800s. Is it?
I refer to Al Jaber.
Al Jaber,
Al Jaber heavy lift, yes. Al Jaber heavy lift.
So Al Jaber have APs, and they come in and you say, I want to lift this big thing, and they go, yeah, no problem. They bring a guy in and he works it all out, and they come in with a big crawler crane and lift it. That's your way into heavy lifting. Pick up somebody with a 200-ton crane or a fleet that's got like cranes bigger than 200 ton in Qatar, and see if you can get a job with them. Because they all see that writing lift plans is value added. I mean, if they pitch up and they go, oh, here's a 200-ton crane, and we'll write you a lifting gear, and we'll supply the riggers. Wow, people just go, there's my problem gone. That's the way in, I'd say. I mean, don't get me wrong, LEA is just a badge, and it's becoming a bit, I shouldn't say this, but it's becoming a bit watered, saturated. Everybody's got LEA, and it's going to be like the riggers and the T-boy is going to have a LEA certificate next. I actually put my secretary on a LEA course.
And sir, just a quick question about lifting, about wind speed rather. So how do you differentiate the wind speed, the acceptable wind speed for this the crane, the tower crane and the mobile crane? So how do you differentiate that?
Well, you'll get the manufacturer's maximum recommended wind speed. And if it's not in the specification, you can get the supplier to tell you. I just know that lattice jib tower crane, crawler cranes are about 13 meters a second, and tower cranes can go up to 20 meters a second, but I wouldn't work them that high because I would work them up to 15, but only on specialized lifts. I'll send a table over to Malavan and he can send it around. This is what I used at the Green Line in Qatar, and it was based on the QCS and local conditions. It's just from experience. You can work out the wind pressures, but I know a small team of Nepali riggers or tagline men cannot hold a large shutter in the wind. And 6 meters a second, I picked that up and it's away and it's spinning. I've had them let go of it, and I had a shutter spinning around for 20 minutes before we had to put it up against a core wall to stop it. And then I got all these near miss reports off the safety because they didn't follow the lift plan. So when it gets up to 5 meters, you have like, I think there's sites where you have actually like a windsock, and then everybody gets like, I remember in sites in Britain, we used to go like green, yellow, red, black. Black meant the whole site shut because the wind was quite strong. But I look at Wind Guru, and I know Wind Guru in the morning is quite accurate, 4 hours, 5 hours into the future. I even know that 4 days in advance, when I push that out and they want a big lift going on a Tuesday, I'll say, no, the wind's too high. And I'll be 90% accurate. I know that day is going to be windy. I can tell people it's going to be windy over the weekend. Have a look at it. It's a great site. It's all color coded, and you can change it from meters per second to knots to kilometers. It's quite good. And it's free, which is a bonus. And you just have that on your computer desktop. Just open it up every day, print it out, and send it out to all your riggers, and just say at 3 o'clock it's going to get really windy, and it's going to be windy till the next day. And then I have a little table that's color coded the same way, so that when it gets up to 7 meters a second, no man baskets, just blanket, no man baskets. 6 meters a second, no more shutters. Rebar up to 9 meters a second with mobile, up to crawler crane, and then only up to 12 meters, 15 meters a second with the tower crane. But 15 meters a second is even dodgy. I wouldn't actually go above 12 meters a second with anything. Unless my project director came down and said, we really need this, I would go up to 15 meters a second, but only with rebar because it's dense.
Okay.
And you'll see that crane operator forcing the crane to stay stable, and they'll be buffeting around, but like a meter on the crane jib trying to hold it still. You can imagine 40 meters up in the air, that load is swinging like a pendulum. Even if he goes a meter to the left, 5 seconds later, or a couple of seconds later, the load's going to the left a meter. A 2-ton bundle of rebar will break somebody's leg. Okay, that's at 15 meters a second. So I would basically look at what you're trying to lift. Okay.
Thank you.
It's all down to the weight, density, surface area. It's just so that I don't think about the calculation. 3 years of pure lifting. All I could suggest is double choke everything. Check your rigging gear. Throw your slings away every 6 months because they get broken down in the sun. It's cheaper to buy a new set than it is to get them tested. Okay.
Right.
That's it.
End of the road.
Yeah, I think we've exhausted it. I think I've done a half an AP course. Actually, this is day 1 of an AP course.
Yeah, exactly. Day 1 and 2 probably with all the questions. It's very true. A lot of the questions, these are being covered on the course, and I think we have informed, Brad is going to run the AP course on the 15th of March. It'll be done with lots of questions, discussions. I think some of you all are interested to join. You mentioned in the questionnaire. So we'll share the brochure, like the timings when we are starting, when we are finishing. Okay. And an important part of this course is it's going to be based more on lift planning and considerably lesser on regulations. So it will be a very skill-based course. So once you complete the course, if you can't do a lift plan, we can shoot Brad. Okay. So
and you get 3 attempts at it, I think Graham was telling me.
One. Come on, not 3. If someone has to take 3, then it shouldn't be an AP. One is enough.
There's a one-day AP course here.
Yes. That's also ours, by the way, Brad. That's for really experienced APs, really experienced ones. Okay. So guys, thank you very much for joining us.
Thanks,
Probably in the next day or 2, we'll share the video, we'll share the slides, and Brad will also be sharing the calculations that he mentioned. So I'll put all of them in a mail and send it to everybody. Now, for the purpose of certificate, just type your name on the chat, which has to appear on your certificate so I can email you. Okay, just put it on the chat, the name that you need on your certificate. Just put it on the chat, then we'll prepare the certificate and email you. Okay, so we're getting the answers. Some good questions, isn't it, Brad?
Challenging. I wish the speakers were a bit more. I'm deaf as it is, but I just can't hear some of the microphone.
No, it's very true. I think even I was having some problem with the bandwidth. So I had to switch to my mobile network. Yeah, well, for some strange reason.
Thanks, guys, for putting up with me for 2 3/4 hours. It's like, yeah, my AP course is only 3 hours a day.
Thanks a lot, Brad.
Okay, no problem. Are you staying on, Malavan, after this?
Yeah, a few minutes. Let's catch up tomorrow, Brad. I'm tired of seeing you today.
There's enough of me. You guys, thanks.
My wife is wondering, why am I spending so much time with you? Wrong message.
Okay. Good, buddy. All the best. Time to leave.
Sure, man. Take care, man. Take care. Take care.
Thank you, Mr. Brad.
Okay, bye, guys. Thanks for listening.
Thank you, Brad. Thank you, Brad. Thank you, Malavan. Thank you all.
Guys, it's really nice to hear from you, man, of a long time.
Thank you, Mr. Malavan.
Same here. Thank you.
Hey, most welcome. Most welcome. We still have a few more people.
Thank you, Malavan.
Hey, most welcome. If you do have some questions about the AP course, you're most welcome to ask.
I mean, if it will be better that if you can share through email along with
yes,
the
definitely.
That will be wonderful.
Definitely.
And this AP will be through online or how it will be?
Online. Now, no chance of running a face-to-face program. See, we've delivered AP trainings for the last 8 years. Now, one of the biggest challenges with the AP courses is the trainer comes from UK, because you got to be at least you got to have 15, 20 years experience in order to deliver a good AP course. So when they come, they stay for 5 days, and you're actually sitting in a high-pack, in a classroom. They're giving you so much of information, probably half of them you do not know. So it's in a very, very pressured environment. So at the end of the day, when you look at how much you're retaining, you're only retaining 25% of what the trainer is saying. So then on the 5th day, you're sitting for an assessment, which is also very tough. So that's why face-to-face, I feel that continuous days of training is not that helpful. So what we have done is we're doing 3 hours in the evening, okay, 3 hours, and then you have breaks in between as well.
Okay.
Okay, so that way the course is evenly spaced out. You're not under pressure, and a lot of what is being taught is based on scenarios. Like, for example, in today's discussion, this is a sample of what we'll be doing in the actual AP course. Most of I worked with several AP training companies from UK. A lot of them, like what I noticed is they give around 45 to 50% emphasis on the UK regulations, which is unfortunately not practiced in this part of the world. And remaining 50%, they focus on planning and sequence of events. So now what we have done in our AP course is we just moved the percentages. So we cover regulations, but not extensively like the other courses. But here we focus more on the actual lift planning. How do you execute the plan, the communication? What are the bigger, the other challenges you're facing?
Okay.
Okay, so that way it's more practical and it works.
Agreed.
We'll be sharing.
Thank you, sir.
Hello.
Good night, Mr. Malavin. Good night. Thank you.
Hey, good night. Good night. Thanks for joining.
How much does it cost? What is the?
It's 4,000 Riyal per person.
How much, sir?
It's 4,000 Riyal, and
Okay.
only 6 people are allowed in a batch.
And it will be 5 days, huh?
No, it will be 10 evenings.
Oh, 10 evenings. Okay.
10 evenings. It will start on the 15th of March and
Okay.
finish on the 26th.
Okay.
So it will be like Monday to Friday. So Saturday and Sunday we won't have classes.
Okay.
Usually, how much does it cost actually when it is in person?
No, that's the price I gave you. It's 4,000 Riyal.
Okay, it's remained same. You mean to say? Thank you.
See, the biggest challenge we have about like few years ago, even if you put around 10 people in a batch, it was not a problem. Now LIA has become very strict because a lot of training companies have manipulated. So they have brought down the number to only 6 per group, so that the trainer is able to spend more time training everyone. Okay.
Yeah, true.
Yes. We delivered, I think, like, how many years now? It's almost around 6 or 7 years since we launched the AP course. Sorry? Or not for me? Excellent. Okay, I'm going to end this meeting. All right.
Yeah. Thank you, sir.
very
Thanks for your
much.
time.
Thank you very much.
Thanks for your support. It's a very good session. Good one. Thank you. See you somewhere.
Hey, thank you. Good night.
Good night, sir.